Have you ever sat in a quiet room, perhaps late at night, when the world outside has finally slowed down and just pressed your hand against a solid surface? Maybe it was the cool, smooth wood of a desk, or the cold glass of a window, or even the fabric of the chair you are sitting in right now. It feels solid. It feels absolute. You press down, and the object resists. It stops your hand. Your senses tell you that you are touching matter, that your skin is making contact with the skin of the world. But this is an illusion. It is a very convincing, very persistent, and very necessary illusion. But it is an illusion nonetheless. In reality, you have never touched anything in your entire life. You have never truly touched the hand of a loved one. You have never truly touched the ground beneath your feet. What you are feeling, that sensation of pressure and solidity, is actually a conversation between invisible force fields happening at a scale so small that your brain cannot even begin to process it. It is the result of a vast, silent, and endless dance performed by the ghostliest, most mysterious entities in the universe. We are going to go on a journey today, a quiet journey into the heart of that mystery. We are going to zoom in, past the skin, past the cells, past the molecules, deep into the subatomic realm, to meet the keeper of our reality. We are going to talk about the electron. You have heard the name 1,000 times. You learned it in school. You know that electricity powers your home. You know that electrons flow through the device you are using to read this right now. But have you ever stopped to ask what an electron actually is? Not what it does, not how we use it, but what it is. If you could hold one in your hand, which, as we will see, is impossible, and look at it, what would you see? Is it a tiny ball? Is it a cloud? Is it a wave? Or is it something so strange that our human language fails to describe it? The answer to that question is one of the deepest mysteries in physics. It is a mystery that challenges our understanding of space, of mass, and of existence itself. To understand the electron, we first have to understand the stage upon which it dances. We have to understand the atom. For thousands of years, humans looked at the world and wondered what it was made of. The ancient Greeks, philosophers like Democritus, imagined that if you cut a piece of cheese in half and then in half again, and kept going, eventually you would reach a tiny, indivisible piece of matter that could not be cut any further. They called this atomos, which literally means uncuttable. They imagined these atoms as solid, hard little spheres, like microscopic billiard balls, latching onto each other to build the world. This idea of the hard, solid atom persisted for centuries. It makes intuitive sense. The world feels hard, so its building blocks should be hard too. But in the late 19th and early 20th centuries, that comfortable picture was shattered. Scientists began to pry open the atom, and what they found inside was shocking. They found that the atom was not a solid sphere at all. It was mostly empty space. To give you a sense of this scale, imagine a large professional sports stadium, one of those giant arenas that can hold 100,000 people. Imagine that this stadium represents a single atom. Now take a small marble, or perhaps a common housefly, and place it exactly in the center of the field, on the 50-yard line. That tiny marble represents the nucleus of the atom, where almost all of the mass resides. It is dense, heavy, and incredibly small. Now, where are the electrons? They are not on the field. They are not in the first rows of seats. In our stadium-sized atom, the electrons would be tiny specks, smaller than grains of sand, whizzing around in the very highest bleachers, way up in the nosebleed section, and everything in between. Everything between that marble on the field and those specks in the upper decks. It is empty. It is a void. It is a vacuum more perfect than anything we can create on Earth. This means that everything you see, everything you touch, is 99.999999% empty space. The chair you are sitting on is empty space. The screen you are looking at is empty space. You are empty space. If you could remove all that empty space from the human body and just pack the actual matter together, the nuclei and the electrons, the entire human race, all 8 billion of us, would fit inside a volume the size of a single sugar cube. So why don't you fall through the chair? Why doesn't your hand pass through the table? That is where the electron comes in. The electron is the guardian of space. Even though they are tiny, and even though they have almost no mass compared to the nucleus, the electrons create a shell, a force field of negative electric charge that defines the boundaries of the atom. When you press your hand against the table, it is not matter hitting matter. It is the electric field of the electrons in your hand, pushing against the electric field of the electrons in the wood. It is a magnetic hovering, a repulsion that is so strong it feels like solidity. But let us look closer at this guardian. Let us look at the electron itself. It was discovered in 1897 by a British physicist named J.J. Thomson. He was experimenting with cathode ray tubes, glass tubes with the air sucked out of them, and he noticed a mysterious glow. He realized that this glow was made of streams of tiny particles. But these particles were different. They were nearly 2,000 times lighter than the lightest atom known at the time, which was hydrogen. Thomson called them corpuscles. It was a cute name, but it didn't stick. Eventually, we settled on the name Electron. This discovery was a watershed moment. It was the first time we realized that the atom was not the smallest thing. There were things inside it. There were subatomic particles. And this is where the mystery deepens. Because as soon as we found the electron, we wanted to measure it. We wanted to know how big it was. It has mass. We know exactly how much mass it has. It is an incredibly small number, but it is precise. The mass of an electron is approximately 9.109 times 10 to the power of negative 31 kilograms. It also has an electric charge. We know that number too. It is negative 1.602 times 10 to the power of negative 19 coulombs. These are fundamental constants of our universe. They are the numbers that make chemistry possible. They are the numbers that allow stars to burn and neurons to fire. But when we try to measure the size of the electron, its radius, its volume, its physical dimension, we run into a wall that defies all common sense. In our everyday world, if something has mass, it has volume. A bowling ball has mass, and it takes up space. A grain of sand has mass, and it takes up space. Even a single atom of gold has mass and takes up space. So, logically, an electron, which has a measurable mass, should also take up space. It should be a tiny ball of negative charge. But when physicists try to measure the radius of an electron, they get a nonsensical answer. They find that the electron appears to have no size at all. It is 0. Now, scientists are very careful people. They don't like to say 0 unless they are absolutely sure. So they say upper limit. Over the decades, we have built more and more powerful machines to try to smash things into electrons or trap them in magnetic fields to see how big they are. We have looked for the structure of the electron. We have looked for a surface. And every single time, with every increase in precision, the electron remains point-like. The current experimental limit tells us that if the electron has a radius, it must be smaller than 10 to the power of negative 18 meters. That is an atometer. To put that in perspective, if an electron were the size of a dust mite, The proton it orbits would be the size of the entire solar system. But the theory, the standard model of particle physics, which is the most successful theory in human history, goes even further. It treats the electron as a point particle, a geometric point, an object with zero radius, zero volume, zero dimension. Let that sink in for a moment in the silence of your room. The electron has mass, it has charge, it has spin, it carries energy. It is the workhorse of the universe. It is the reason light exists. It is the reason you exist. And yet, it has no size. How can something have properties but no dimension? How can something have weight but no width? If you have a bag of marbles, the bag gets bigger as you add marbles. But you could theoretically stack an infinite number of electrons on top of each other, and they would still take up zero space, if not for their repulsion. It challenges our definition of what it means to be. If something takes up no space, is it really there? Or is it just a coordinate in the fabric of reality where a certain set of rules applies? This is the central paradox of the electron. It is a ghost that carries a shield. It is a nothing that creates everything. When we look at the objects around us, we see form and structure. We see the curve of a vase or the straight line of a book. But if we look with the eyes of a physicist, we see that all this form is built out of point-like ghosts swirling in a vast emptiness. The solidity of the world is a trick of the light, a consequence of how these zero-dimensional points interact with each other. But wait, you might say, if it is a point, what is inside the point? This is the question that keeps physicists awake at night. Is it truly a singularity? Or is there something deeper? String theory, one of the great contenders for a theory of everything, suggests that if we could zoom in far beyond the reach of any microscope, far beyond the reach of any particle accelerator, we would see that the point is not a point at all. It is a tiny vibrating loop of energy, a string. And the way that string vibrates determines what the particle is. If it vibrates one way, it is an electron. If it vibrates another way, it is a quark. In this view, the electron is like a note played on a cosmic cello. It is music. It is not a thing. It is a song. But string theory is unproven. For now, we are left with the standard model and the point particle. And this point particle has another trick up its sleeve. It is never alone. Even a single electron floating in the deepest void of intergalactic space is not truly alone. Because of the strange rules of quantum mechanics, the electron is surrounded by a cloud of virtual particles. These are ghostly particles that pop in and out of existence, borrowing energy from the vacuum and paying it back in a fraction of a second. The electron is constantly interacting with this cloud. It is like a celebrity walking through a crowd, surrounded by paparazzi. The bare electron, the thing at the center, might be different from the dressed electron that we actually observe. We can never see the naked electron. We only see it through the veil of this virtual cloud. So, when we ask what is inside an electron, the answer might be the entire universe, or at least a connection to the fundamental fields that make up the universe. The electron is a knot in the fabric of these fields. It is a permanent ripple in the electron field that permeates all of space. Imagine a vast, calm ocean extending infinitely in all directions. That is the electron field. Now, tap the surface of the water, that ripple, that localized disturbance moving across the surface. That is the electron. The water is the reality. The particle is just the shape the water takes for a moment. But this ripple is stable. It doesn't fade away like a ripple on a pond. It persists for billions of years. An electron created in the Big Bang is still here today, identical to every other electron in the cosmos. There are approximately 10 to the power of 80 electrons in the observable universe. That is a 1 followed by 80 zeros, and every single one of them is identical. You cannot distinguish one electron from another. If you swap the electron in your fingertip with an electron in the core of a star, a billion light years away, nothing changes. The universe doesn't notice. This is a profound realization. It suggests that maybe there aren't 10 to the power of 80 different electrons. Maybe, as the physicist John Wheeler once suggested to Richard Feynman, there is only one electron, one single entity, weaving backwards and forwards through time and space, appearing everywhere at once, creating the illusion of the many. It is a wild idea, a poetic idea, and while it probably isn't literally true, it speaks to the deep interconnectedness of these particles. As we lie here in the quiet, thinking about this, the solidity of the room seems to soften. The walls are no longer barriers. They are clouds of probability. The air you breathe is a mixture of vibrating fields. The sensation of your body against the bed is a magnificent electromagnetic hover. You're floating. You're always floating. You are a collection of ancient, indestructible points of energy, organized into a thinking, feeling pattern, drifting through a universe that is mostly silence and shadow. And at the heart of every atom in your body, these electrons are spinning, or rather possessing a property called spin, which is yet another mystery we will explore, dancing their eternal dance. They have been dancing since the dawn of time, and they will continue to dance long after the stars have gone dark. We are just beginning to peel back the layers of this mystery. We have looked at the electron from the outside. We have touched the surface of the problem. But to truly understand what is inside, to truly understand why this tiny, zero-dimensional speck is the key to our existence, we have to go deeper. We have to look at how it moves. We have to look at how it can be in two places at once. We have to look at the fact that it is both a particle and a wave, a solid thing and a ghost. The journey into the electron is a journey into the heart of reality itself. It is a journey that will take us from the comfortable world of the visible to the bizarre, mind-bending world of the quantum. And as we take this journey, remember, you are not just an observer. You are made of this mystery. The very neurons in your brain that are processing these words are firing because electrons are moving across cell membranes. The light entering your eyes is interacting with the electrons in your retinas. You are the mystery looking at itself. You are the universe wondering what it is made of. And that, perhaps, is the most beautiful thought of all. The popular image of the atom, the one that is burned into our collective consciousness from high school textbooks and science fiction logos, is a lie. You know the image I am talking about. It looks like a miniature solar system. There is a nucleus in the center, representing the sun, and there are little electrons whizzing around it in neat circular orbits, just like planets orbiting a star. It is a beautiful image. It is orderly. It is mechanical. It makes us feel like the universe is a clockwork mechanism, predictable and safe, repeating the same patterns from the scale of the galaxy down to the scale of the microscopic. We find comfort in this idea. We want to believe that the tiny particles that make up our bodies and our world behave like tiny rocks, following strict paths, obeying the laws of motion that we can see and understand. But as we journey deeper into the reality of the electron, we have to let go of this comfort. We have to shatter the clockwork, because the reality of what an electron is doing inside an atom is far stranger, far more ghostly and far more beautiful than a miniature solar system. The electron is not a planet. It is not a rock. It is not a solid little ball traveling along a line. If you could shrink yourself down and enter the atom, you would not see particles orbiting the center. You would see something that looks more like a cloud, a fog, a shimmering haze of pure possibility. This is where the story of the electron transforms from a story about matter into a story about probability. In the early 20th century, as physicists probed deeper into the subatomic world, they realized that the old rules simply did not apply. If an electron were just a charged ball orbiting a nucleus, the laws of electromagnetism say it should constantly radiate energy. It should spiral inward, crashing into the nucleus in a fraction of a second. Every atom in the universe should collapse instantly. Matter should not exist. You should not exist. The fact that you are here, the fact that the book on your shelf stays on the shelf, the fact that the stars shine steadily, is proof that the electron is obeying a different set of rules. It is obeying the rules of quantum mechanics. And the first rule of this strange new world is that the electron is not just a particle. It is also a wave. Imagine a guitar string. When you pluck it, the string vibrates. It creates a standing wave, a pattern of motion that stays in place, oscillating up and down. The string isn't moving from one end of the guitar to the other. It is vibrating in a specific shape. Now, imagine that the electron is not a point moving through space, but a vibration wrapped around the nucleus. It is a three-dimensional standing wave. It is a hum. It is a note played on the instrument of space-time. This is why the electron doesn't crash into the nucleus. It isn't falling in the traditional sense. It is a stable wave pattern that fits perfectly into the space available, like a sound wave resonating inside a bell. This realization changes everything. It means that the electron is not located in one specific spot at one specific time. It is smeared out. It exists in a state of superposition, occupying many different places simultaneously. When we try to visualize this, we use the concept of an orbital. But be careful with that word. An orbit is a path, like a train track. An orbital is something else entirely. An orbital is a region of space where you are likely to find the electron if you go looking for it. It is a probability cloud. Imagine a moth flying around a street lamp at night. It moves so fast and so chaotically that you cannot see the individual moth. You just see a blur, a fuzzy halo of light around the lamp. The electron is like that blur, but with a twist. The moth is actually in one place at a time, moving quickly. The electron, according to quantum mechanics, is literally the entire blur at once. It is a ghost that haunts a specific volume of space. In the simplest atoms, like hydrogen, this cloud is shaped like a perfect sphere, a ball of fog. The electron is not on the surface of the sphere, nor is it inside the sphere at a specific point. The electron is the sphere. It is a cloud of negative charge density, thickest near the center and fading out toward the edges like a breath of mist in the cold air. But nature is not content with just spheres. As we add more electrons to an atom, the music gets more complex. The waves start to interfere with each other, forcing the electrons into new and exotic shapes. These are the shapes of the building blocks of reality. After the simple sphere, which physicists call the S orbital, we get the P orbitals. These look like dumbbells, or hourglasses, or two teardrops meeting at the points. Imagine two balloons tied together at the knot. The electron in a P orbital exists in both lobes of the dumbbell at the same time. It is on the left side and the right side simultaneously, but never in the middle. The center, the knot where the two lobes meet, is a node, a point of zero probability. The electron can never be there, yet, somehow, it is on both sides. It is as if a person were standing in the living room and the kitchen at the exact same moment, without ever passing through the hallway that connects them. This is the magic of the quantum world. The electron does not need to cross the space to be on the other side. It simply is, on both sides. Then come the d orbitals, which look like four-leaf clovers or two dumbbells crossed over each other, and the f orbitals, which are complex, multi-lobed structures that look like bundles of balloons or exotic flowers. These shapes, spheres, hourglasses, clovers, flowers, are the architecture of chemistry. When atoms come together to form molecules, when carbon bonds with oxygen to let you breathe, when hydrogen bonds with oxygen to make the water you drink, they are essentially clicking these ghost clouds together like pieces of a four-dimensional puzzle. The solidity of the world, the structure of crystals, the geometry of snowflakes, the spiral of your DNA, all of it arises from the specific mathematical shapes of these electron clouds. You are made of geometry. You are made of probability waves locking into place. There is a profound silence at the heart of this activity. We are used to thinking of motion as noisy. Cars roar, engines hum, feet stomp. But the motion of the electron is silent. It is a movement without friction, a dance without footsteps. And there is a fundamental limit to how much we can know about this dance. This is the famous Heisenberg uncertainty principle. It states, with absolute mathematical authority, that you cannot know both the position and the momentum of an electron with perfect precision. The more you try to pin down where the electron is, the less you know about where it is going. It is not a failure of our measuring instruments. It is not because our microscopes are not good enough. It is a fundamental property of the universe. The electron refuses to be pinned down. It demands a certain amount of freedom, a certain amount of fuzziness. If you try to squeeze it into a corner to say, you are exactly here, its momentum becomes infinite, and it explodes outward with tremendous energy. The electron needs room to breathe. It needs the uncertainty to exist. This fuzziness implies that, at the fundamental level, reality is not sharp. If you look closely enough at the edge of a table, or the tip of a needle, or the pupil of your eye, the boundaries begin to blur. There is no sharp line where the atom ends and the empty space begins. There is just a gradual fading of the probability cloud, a gentle tapering off of the electron's presence. The edges of things are not walls. They are gradients. We live in a world of soft transitions, of merging clouds, of interactions that happen in the gray areas of probability. The universe is more like a watercolor painting than a technical drawing. The colors bleed into each other. The forms are suggested rather than defined. And yet, from this softness, the hardness of the world emerges. The vast collective behavior of trillions upon trillions of these fuzzy, ghostly particles creates the undeniable solidity of the chair beneath you. But perhaps the most mind-bending aspect of the electron's life inside the atom is how it moves between these energy levels, these clouds. We are used to things moving continuously. If you want to go from the first floor of a building to the second floor, you have to climb the stairs. You have to pass through every point in between. You cannot just vanish from the lobby and appear on the balcony. But the electron can. In fact, it must. When an electron gains or loses energy, perhaps by absorbing a photon of light, it jumps from one orbital cloud to another, but it does not travel through the space between them. It simply ceases to exist in the lower energy state and instantly begins to exist in the higher energy state. This is the quantum leap. It is true teleportation. One moment, the electron is vibrating in a spherical S-cloud. The next moment, it is vibrating in an hourglass P-cloud. It didn't fly there. It didn't shrink or grow. It just changed its state of being. This phenomenon is happening right now, trillions of times a second, all around you. It is happening in the filament of the light bulb above your head. Electrons are jumping down from higher energy levels to lower ones, and in the process, they are releasing tiny packets of light, photons, that travel to your eye. The light you see is the exhaust of electrons teleporting. It is the visible echo of a quantum jump. Every color you have ever seen, the red of a rose, the blue of the sky, the green of the grass, is a specific frequency of light, released or absorbed by an electron, making a specific jump between specific clouds. The palette of the universe is determined by the spacing of these electron orbitals. We are literally seeing the internal structure of the atom painted in light. This brings us back to the vast emptiness we spoke of earlier, the stadium with the marble and the nosebleed seats. That space between the nucleus and the electron shells is not just empty. It is filled with fields, with potential, with the tension of electromagnetic forces. It is a charged silence. And the electron, in its cloud-like state, acts as the guardian of that space. It puffs up the atom. It gives it volume. Without the electron's wave nature, the atom would collapse. The electron, by refusing to be confined, by demanding its quantum space, creates the volume of matter. It creates the size of things. You are the size you are because your electrons refuse to be crushed. You are a standing wave of resistance against the collapse of the universe. Think about the implications of this. We tend to identify with the stuff of our bodies, the heavy nuclei, the carbon, the oxygen. But the character of the elements, the way they behave, the way they bond, the way they create life, is entirely determined by the electrons. The nucleus is just the anchor, the heavy center that holds the whole thing together. The electrons are the personality. They are the social butterflies of the atomic world, reaching out to touch other atoms, sharing their clouds, trading places, locking together to build molecules. Chemistry is just the social life of electrons. Biology is just the complex dance of electrons. Consciousness, your very ability to think about these things, is the result of electrons flowing through the complex circuits of your brain. So, when we ask what is inside an electron, we are led to a strange conclusion. The electron isn't a box that contains something. It is a ripple in a field that contains everything. It is a point of connection. It is a manifestation of the universe's desire to be something rather than nothing. In the deep silence of the subatomic realm, where the concepts of here and there lose their meaning, the electron exists as a pure potentiality. It waits for an interaction. It waits for an observer. It waits to be part of something larger than itself. As you rest in the quiet of your room, try to visualize this new model. Replace the little solar systems in your mind with beautiful, shimmering clouds of light. See them breathing, see them pulsing, see the atoms in the wall not as hard bricks, but as vibrating harmonies of energy. See your own hand as a collection of these clouds, hovering, humming, interacting with the clouds of the blanket or the chair. The world is not a machine. It is a symphony played on instruments so small they have no size, by players who are everywhere at once. And the music they play is the reality you experience every single moment of your life. This realization can be unsettling, but it can also be deeply peaceful. To know that at the most fundamental level, we are not rigid, solid things, but fluid, dynamic, interconnected fields of energy. We are woven into the fabric of the cosmos by these tiny, ghostly threads. We are ancient. The electrons in your body are as old as the universe itself. They were forged in the first moments of the Big Bang, and they have been dancing ever since. They have been part of stars. They have been part of comets. They have been part of dinosaurs and ferns and oceans, and now, for this brief, flickering moment in cosmic time, they are part of you. They are holding you together. They are letting you feel. They are letting you wonder. We have moved from the solid illusion of the surface to the ghostly cloud of the orbital. We have seen that position is a myth, and that movement is teleportation. But there is another layer to this mystery, a layer that involves a property so strange, so counterintuitive, that the founders of quantum mechanics struggled to believe it was true. It is a property that makes the electron act like a tiny magnet, spinning forever without ever slowing down, spinning even though it is a point with no size to spin. This is the mystery of spin, and it is the key to understanding why the universe has structure at all. Why don't all the electrons just fall into the lowest energy cloud and stay there? Why do they stack up layer upon layer, building the complex periodic table of elements? The answer lies in the exclusion principle, a rule of cosmic politeness that prevents electrons from occupying the same space. And that rule depends on spin. But what is spin? If the electron is a point, how can it rotate? The journey inward continues. We have passed through the cloud. We have listened to the hum. Now we must look at the dancer itself and ask how it moves. We must confront the paradox of intrinsic angular momentum. We are going to dive into the magnetic heart of the electron, where we will find the secret of stability in a chaotic universe. In our quiet exploration of the subatomic world, we have encountered a ghost that has no size, and a cloud that is everywhere at once. We have learned that the solid ground beneath our feet is actually a shimmering mirage of probability waves. But there is another secret hidden inside the electron, a property so strange and so fundamental that it is responsible for the shape of every object in the universe. Without this property, all matter would collapse into a formless soup. There would be no chemistry, no biology, no stars, and certainly no human beings to wonder about them. This property is called spin. And like everything else in the quantum realm, it is not what it seems. Imagine a child's toy top spinning on a wooden floor. It hums as it rotates, balancing on a fine point, blurring with the speed of its motion. Or imagine the earth spinning on its axis, creating the cycle of day and night. We are used to things spinning. Rotation is a fundamental part of our physical experience. When physicists first discovered that electrons had a magnetic field, that they acted like tiny bar magnets with a north and south pole, they naturally assumed that the electron was spinning like a tiny planet. After all, a moving electric charge creates a magnetic field. If a ball of charge rotates, it becomes a magnet. It made perfect sense. They even named the property spin because the metaphor was so irresistible. But as they looked closer, the metaphor broke down completely. In fact, it shattered. Here is the problem. We know, or at least our best theories tell us, that the electron is a point particle. It has a radius of 0. If you try to calculate how fast a point with 0 radius would have to spin to generate the magnetic field we observe, you get an impossible answer. The surface of the electron would have to be moving faster than the speed of light. And, as Einstein taught us, Nothing can move faster than light. So, the electron is not spinning. It is not rotating on an axis. It is not twirling like a ballerina. And yet, it possesses angular momentum. It behaves exactly as if it were spinning. This is the paradox of intrinsic angular momentum. Think of it this way. The electron doesn't spin. The electron is spin. It is a fundamental property built into its very existence, just like its mass and its charge. You cannot stop an electron from spinning. You cannot speed it up or slow it down. It spins forever, with a fixed value, from the moment of its creation until the end of time. It is a permanent, unchangeable aspect of what it is. It is as if the concept of rotation was distilled into a pure, abstract number and stamped onto the fabric of the particle. This intrinsic spin is the source of the electron's magnetism. Every electron in your body is a tiny, microscopic magnet. You are a collection of trillions upon trillions of magnetic fields, all interacting, all dancing, all aligning and misaligning in the quiet dark of your atomic structure. But the mystery goes deeper. In the world we know, a spinning object can be tilted at any angle. A top can lean a little to the left, a little to the right, or spin perfectly upright. The electron, however, lives in the quantum world, and the quantum world is digitized. It is granular. When we measure the spin of an electron, we find that it can only point in two directions, up or down. That's it. There are no diagonals. There are no halfway points. It is a binary switch, +1, 2, or 1, 2. It is strictly quantized. When an electron is in a magnetic field, it either aligns with the field, spin down, or against it, spin up. It snaps into one of these two states instantly. This binary nature of the electron leads us to one of the most profound principles in all of physics, a rule so absolute that it governs the structure of all matter. It is called the Pauli exclusion principle. Named after the Austrian physicist Wolfgang Pauli, this rule is the reason you are not a puddle of goo. It is the reason the floor is solid. It is the reason the universe has variety. The principle is deceptively simple. No two electrons in the same atom can occupy the exact same quantum state. They cannot have the same energy, the same orbital shape, the same orientation, and the same spin. They effectively demand their own personal space. Imagine a theater with a limited number of seats. The Pauli exclusion principle says that only one person can sit in each seat. You cannot sit on someone's lap. You cannot stack people on top of each other. Once a seat is filled, the next person must find a different seat, perhaps in a row further back or up in the balcony. Now, apply this to the atom. The seats are the orbitals, those ghostly probability clouds we talked about earlier. The lowest energy orbital, the small spherical cloud closest to the nucleus, has only one seat shape. But because electrons have spin, and spin can be either up or down, this orbital can actually hold two electrons, one with spin up and one with spin down. They are like a pair of dancers, perfectly matched but opposite, sharing the same space without violating the rules. But what happens when a third electron comes along? The first orbital is full. The up seat is taken. The down seat is taken. The third electron cannot squeeze in. The exclusion principle forbids it. It is a cosmic law that cannot be broken. So, the third electron is forced to move to a higher energy level, to a larger orbital, further away from the nucleus. It has to take a seat in the second row. This simple rule, this refusal of electrons to occupy the same state, forces the atom to grow. It forces the electrons to stack up in layers, shell by shell, like the layers of an onion. If electrons didn't have spin, or if they didn't obey the Pauli exclusion principle, they would all just fall into the lowest, smallest orbital. Every atom in the universe would be tiny and identical. There would be no chemistry because there would be no outer shells to bond with other atoms. All matter would be a dense, boring, uniform condensate. But because electrons are fermions, the family of particles that obey this rule, they push each other away. They build complex structures. They create the periodic table of elements. Think about the carbon atom, the basis of all life on Earth. It has 6 electrons. 2 fit in the inner shell. The next 4 are forced into the second shell. Because that second shell is half full, it is hungry. It wants to find 4 more electrons to complete its set, to fill its seats. This hunger, this drive to fill the outer shell, is what makes carbon bond so readily with other elements. It is the reason carbon can form long chains, complex rings, and the intricate molecules that make up your DNA. The entire complexity of biology, the very existence of life, is a direct consequence of the electron's spin and its refusal to share its quantum state. Your life is an elaborate workaround for the Pauli exclusion principle. This principle is also responsible for the solidity of matter. We said earlier that solidity is an illusion created by electromagnetic fields. That is true, but it is only half the story. The other half is degeneracy pressure, which is just a fancy name for the resistance electrons exert when you try to squeeze them too close together. When you push your hand against the table, you're trying to force the electrons in your hand into the same space as the electrons in the wood, but their quantum states are already full. They cannot overlap. The universe pushes back. The resistance you feel, the hardness of the wood, is the Pauli exclusion principle in action. It is the force of quantum individuality. It is the electron saying, I am here, and you cannot be here too. There is a deep philosophical beauty in this. At the most fundamental level, existence requires separation. It requires distinction. If everything were allowed to merge perfectly, to occupy the same state, the universe would lose its structure. It would lose its complexity. It is the resistance, the exclusion, the boundary between this and that allows form to emerge from the void. We often think of separation as a negative thing, as a barrier to connection. But in the quantum world, separation is the creator of form. It is the architect of diversity. The electron's stubborn refusal to merge is what gives the flower its petals and the mountain its height. This spin, this intrinsic angular momentum, also connects the electron to the deep geometry of space-time. There is a mathematical strangeness to spin that is hard to visualize, but wonderful to contemplate. If you take a normal object, like a book, and rotate it 360 degrees, one full circle, it returns to its original orientation. It looks the same, but an electron is different. If you rotate an electron 360 degrees, it does not return to its original state. Its wave function is inverted. It is upside down in a mathematical sense. You have to rotate it another 360 degrees, a total of 720 degrees, to get it back to where it started. Imagine walking around a sculpture in a museum. You walk one full circle, and you expect to see the front of the sculpture again. But instead, you see the back. You have to walk a second full circle to see the front. That is the geometry of the electron. It lives in a world where a circle is twice as long as we think it is. It suggests that the electron is plugged into a layer of reality that is richer and more complex than our three-dimensional intuition can grasp. It is tethered to the universe in a way that requires a double turn to untangle. This property is crucial for the mathematics of quantum mechanics, and it is yet another sign that our everyday experience of space is just a simplified shadow of a deeper, stranger truth. As we rest here, letting these concepts wash over us, the silence of the room feels different. It is not an empty silence. It is a balanced silence, a tense, dynamic stability. The billions of trillions of electrons in the walls, in the air, in your body, are all spinning. Half of them spin up, half of them spin down, pairing off, locking into their energy levels, pushing against each other to maintain the volume of the world. It is a vast, invisible grid of exclusion and connection, a cosmic bureaucracy where every particle has its file, its place, its ID card, and no two are ever allowed to be the same. And this spin is not just about structure, it is about information. In recent years, scientists have learned to manipulate the spin of individual electrons. This is the basis of spintronics and quantum computing. In a normal computer, a bit is either a 0 or a 1, represented by the flow of electricity. But a quantum bit, or qubit, can use the spin of an electron. Because of quantum superposition, the electron can be spin up and spin down at the same time. It can hold multiple states simultaneously. A computer built on this principle could solve problems in seconds that would take a traditional supercomputer millions of years. We are learning to harness the ghostly, spinning heart of the electron to think in new ways. We are learning to compute with the fabric of reality itself. But let us step back from the technology and return to the wonder. Think about the isolation of the electron. It is a point. It is alone in its exclusion. It pushes others away. And yet, this very isolation is what allows it to bond. Because it has empty slots in its outer shells, it reaches out. It shares. A chemical bond is essentially two atoms agreeing to share a pair of electrons, one spin up, one spin down, in the space between them. They merge their clouds. They form a bridge. The exclusion leads to connection. The structure of the molecule, the structure of life, is built on this delicate balance between stay away and come closer. It is a gentle paradox. The electron is the ultimate individualist, refusing to conform, refusing to overlap. And yet, it is the ultimate social creature, constantly seeking a partner to cancel out its spin, to fill its shell, to lower its energy. It seeks peace. Every chemical reaction in the universe, from the burning of a star to the digestion of your food, is just electrons seeking a lower energy state. They are seeking rest. They are moving, jumping, spinning, and bonding, all in an eternal quest for equilibrium. They want to settle down. They want to find their place in the cosmic puzzle and stay there. The energy that powers your body right now is the energy of electrons falling into more comfortable arrangements. When you breathe in oxygen, you are providing a comfortable home for electrons that are tired of being trapped in high-energy bonds in your food. They flow to the oxygen, settling into a tight, low-energy embrace with hydrogen to form water. And in that fall, in that sigh of relief, they release the energy that keeps your heart beating and your mind thinking. You are alive because electrons want to be at peace. So, as we go deeper into the mystery of what is inside an electron, we find that it is not just a thing. It is a set of rules. It is a collection of numbers, mass, charge, spin. It is a cloud of probability. It is a tiny magnet. But above all, it is an agent of structure. It is the invisible architect that takes the raw chaos of the Big Bang and organizes it into the intricate, beautiful, solid world we see today. It creates the stage on which life can play. But we are not done yet. We have looked at the electron in isolation. We have looked at it in the atom. We have looked at its spin. But there is one more question, perhaps the deepest of all. Where does it get its mass? Why does it weigh anything at all? And what happens when an electron meets its mirror image, its dark twin, the antimatter positron? To understand this, we have to go even further. We have to dive into the vacuum itself. We have to look at the sea of virtual particles that seethes in the emptiness of space. We have to ask how the electron talks to the rest of the universe. We have to explore the dance of light and matter, the theory of quantum electrodynamics, which Richard Feynman called the jewel of physics. The journey is far from over. The electron has more secrets to tell, secrets about the nature of empty space, secrets about the origin of mass, secrets about the possibility that the vacuum is not empty, but full. As we prepare to descend to this next level, take a moment to feel the spin within you. Feel the stability of your own existence. You are a masterpiece of exclusion. You are a cathedral of spin. And you are safe, held together by the gentle, stubborn laws of the quantum world. If you could take a jar and scoop up a cup of outer space from the deepest, darkest void between the galaxies and bring it back to a laboratory, what would you have? You would remove every atom of gas, every drifting molecule of dust, every stray photon of light, until you had absolutely nothing left. A perfect vacuum, a void. Common sense tells us that this void is empty. It is a stage with no actors. It is a silence with no sound. But as we continue our journey into the heart of the electron, we have to discard common sense once again, because in the quantum universe, there is no such thing as empty. The void is not a stage. It is a soup. It is a roiling, boiling, seething ocean of energy that is never, ever still. And the electron, that tiny point of mass and spin we have been studying, is swimming in this ocean. In fact, it is inseparable from it. To understand what is inside the electron, we have to understand the water in which it swims. This concept brings us to one of the most beautiful and strange theories in the history of science, quantum electrodynamics, or QED. The physicist Richard Feynman, a man who played bongos and cracked safes and understood the universe better than almost anyone, called this theory the jewel of physics. It is the theory of light and matter. It is the story of how electrons talk to each other, and it reveals that the electron is a master of disguise. Imagine the electron floating in that jar of perfect vacuum. According to Heisenberg's uncertainty principle, which we touched on earlier, nature allows for a strange kind of accounting. You can borrow energy from nowhere as long as you pay it back very, very quickly. The more energy you borrow, the faster you have to return it. In the vacuum of space, purely out of nothingness, pairs of particles are constantly popping into existence. A particle and its antiparticle, an electron and a positron, blink into being, borrow energy from the vacuum, live for a fraction of a nanosecond, and then snap back together, annihilating each other and returning the energy to the void. This is happening everywhere, all the time, right in front of your nose, right in the empty space of the atom. Trillions of these virtual particles are living and dying in the blink of an eye. Now, place a real permanent electron into this chaotic sea. What happens? The electron has a negative charge. As it sits there, it exerts an electric force on the virtual particles popping in and out around it. It attracts the positively charged virtual positrons, and it repels the negatively charged virtual electrons. For that brief instant that they exist, the virtual positrons tend to cluster closer to the real electron, while the virtual electrons are pushed a little further away. The result is a cloud of virtual activity that surrounds the central electron. This is not the orbital cloud we talked about before. This is much, much smaller and much more fundamental. It is a shroud. It is a cloak. The virtual positrons act like a screen, masking the true nature of the electron at the center. They shield its charge. This phenomenon is called vacuum polarization, and it means that we never, ever see the bare electron. We never see the naked particle. We only ever see the electron plus its cloak. We only see the celebrity surrounded by the paparazzi. This leads to a mind-bending possibility. The bare charge of the electron, the charge it would have if we could strip away the vacuum cloak, might be infinite. It might be a singularity of pure, infinite electric power. But the vacuum shields it, cancels out most of that infinite rage, and leaves us with the gentle, finite charge that powers our batteries and runs our chemistry. The electron we know, the electron we use, is a compromise between a monster and a void. It is a dressed particle, wrapped in the fabric of the universe itself. This relationship between the electron and the vacuum is described with terrifying precision by quantum electrodynamics. When physicists calculate the properties of the electron using this theory, they have to account for every single way the electron can interact with this virtual cloud. They have to calculate the probability of the electron emitting a virtual photon and catching it again. They have to calculate the probability of that virtual photon turning into a virtual electron-positron pair, which then annihilates back into a photon, which is then caught by the original electron. It is a dance of infinite complexity. And here is the wonder of it. It works. It works better than any theory humans have ever devised. There is a property of the electron called the G factor, which relates to its magnetism. It is a measure of how strong a magnet the electron is. We can measure this number in the laboratory with incredible accuracy, using giant magnetic traps to hold a single electron in place for months, listening to its spin. And we can calculate this number using the equations of QED, summing up the effects of the virtual cloud. The two numbers match. But they do not just match a little bit. They match to more than 12 decimal places. To give you a sense of this precision, imagine you wanted to measure the distance from New York to Los Angeles. That is about 2,450 miles. If you measured it with the precision of QED, you would know the distance to within the width of a single human hair. That is how well we understand the electron's relationship with the vacuum. It is the greatest triumph of the human intellect. We have reached into the invisible, calculated the dance of ghosts, and found that the math describes reality perfectly. So, when you ask what is inside an electron, the answer expands. Inside the electron's sphere of influence is a reflection of the entire electromagnetic universe. It is a knot that pulls the vacuum around it like a blanket. And in that blanket, we find the echo of antimatter. We mentioned the positron. This is the antimatter twin of the electron. It has the same mass, the same spin, but a positive electric charge. The discovery of the positron is a story of pure mathematical magic. In 1928, a physicist named Paul Dirac was trying to write an equation that would describe the electron moving near the speed of light. He wanted to combine quantum mechanics with Einstein's special relativity. He sat in his room at Cambridge, staring into the fire, manipulating symbols of algebra. He found an equation, the Dirac equation, that was beautiful and simple. It described the electron perfectly, but the equation had a quirk. It had two solutions. Just as the square root of 4 can be 2 or -2, Dirac's equation allowed for an electron with positive energy and an electron with negative energy. Most physicists would have thrown the negative solution away as a mathematical artifact, a mistake. But Dirac was a believer in the beauty of mathematics. He trusted his equation more than he trusted his intuition. He realized that this negative energy electron looked exactly like a positively charged particle. He predicted that antimatter must exist. 4 years later, in 1932, an experimenter named Carl Anderson saw a track in a cloud chamber that curved the wrong way. It was an electron, but it was positive. It was the positron. Dirac's math had conjured a new form of matter out of the thin air of logic. This tells us something profound about the electron. It is not a unique, solitary object. It is part of a duality. For every electron, there is a potential anti-electron. They are mirror images, and if they ever meet, they annihilate. They vanish in a flash of pure gamma rays, returning their borrowed mass to the energy of the universe. The electron holds within it the potential for its own destruction. It is a stable particle, yes. An electron left alone will live forever, but its existence is balanced on the edge of this symmetry. Now, let us go even deeper into the what of the electron. We have talked about mass. We said the electron has a mass of about 9.1 times 10 to the power of negative 31 kilograms. But where does this mass come from? For a long time, this was a mystery. Why do things resist being pushed? Why does the electron have this specific weight and not another? The answer, we now believe, lies in yet another field, yet another ocean that fills the universe. This is the Higgs field. You have heard of the Higgs boson, the God particle discovered at CERN in 2012. The boson is just a ripple in the Higgs field, much like the electron is a ripple in the electron field. But the Higgs field is special. It is sticky. It is like a cosmic molasses that permeates every inch of space. As the electron moves through the universe, it has to wade through this Higgs field. The interaction drags on it. It slows it down. It gives it inertia. Imagine walking through water. It is harder to move than walking through air. The water resists you. That resistance is what we feel as mass. The electron, which is a point of zero size, acquires its mass by rubbing against the Higgs field. If the Higgs field were to vanish tomorrow, the electron would lose its mass instantly. It would become light. It would zoom away at the speed of light, unable to form atoms, unable to slow down, unable to be you. So, the inside of the electron is actually an outside. Its properties, its charge, its mass, its magnetism are all defined by how it interacts with the invisible fields around it. It is a node in a network. It is defined by its relationships. The charge is a relationship with the electromagnetic field. The mass is a relationship with the Higgs field. The spin is a relationship with the geometry of space-time. If you took away the universe, you wouldn't just be left with an electron in the dark. The electron itself would cease to have meaning. It is a creature of context. This realization invites a sense of deep humility. We tend to think of objects as independent, self-contained things. A rock is a rock. A chair is a chair. But physics tells us that nothing is self-contained. Everything is woven together. The electron in your fingertip is intimately connected to the vacuum that stretches to the edge of the cosmos. It is interacting with fields that permeate the entire universe. You are not in the universe. You are of the universe. You are a localized vibration of the same vast ancient fields that make up the stars and the galaxies. Let us return to the quiet of your room. The air is still. The night is dark. But now, with your mind's eye, you can see the truth. The darkness is not empty. It is shimmering with virtual particles, a ghostly fireworks display that never ends. The silence is not silent. It is filled with the hum of quantum fields, the vibration of strings, the sticky drag of the Higgs, and you, sitting in the middle of it all, are a gathering of these mysteries. Your body is a galaxy of electrons, 7 octillion of them. That is a 7 followed by 27 zeros. Each one is a point of zero size. Each one is spinning forever. Each one is wrapped in a cloak of virtual particles. Each one is wading through the cosmic molasses of the Higgs field. And together, through the miracle of the Pauli exclusion principle and the dance of quantum wave functions, they create the stable, breathing, thinking form that is you. It is a miracle of organization. How do 7 octillion chaotic quantum ghosts agree to be a human being? How do they agree to be a heart that beats and a brain that wonders? They do it through the exchange of light. This is the final piece of the electron's immediate puzzle. How do electrons talk to each other? They don't shout. They don't touch. They throw photons. The photon is the particle of light, the carrier of the electromagnetic force. When one electron pushes another, it does so by firing a virtual photon at it. It is a game of catch. One electron shudders and throws a photon. The other catches it and shudders in response. This exchange of light is what holds atoms together. It is what binds molecules. It is the glue of reality. We live in a universe made of matter and light. But in the deep language of QED, matter and light are just two sides of the same coin. Interactions between electrons and photons are the fundamental events of our world. Every time you see something, an electron in the object has shaken and thrown a photon at your eye, where an electron in your retina has caught it. Vision is a handshake between electrons. Consider the light from a star. A star, like Sirius, the brightest star in our night sky, is 8.6 light-years away. In the fiery plasma of that star, an electron jumped from a high orbital to a low orbital. In that quantum leap, it released a photon. That photon traveled through the vacuum for 8 years, dodging dust and gas, crossing the immense, cold distance of interstellar space. It passed through Earth's atmosphere, through the lens of your eye, and landed on your retina. There, it hit an electron in a molecule of rhodopsin. That electron absorbed the photon's energy and jumped to a higher orbital. That jump changed the shape of the molecule, which triggered a nerve impulse, which traveled to your brain. And in that moment, you saw the star. You touched the star. The electron in your eye and the electron in the star were connected by a bridge of light across the void. The universe is a web of these connections, a vast network of calls and responses, all mediated by the humble, mysterious electron. So, what is inside an electron? Light is inside it. Mass is inside it. The vacuum is inside it. The history of the universe is inside it. It is the smallest thing we know, and yet it contains the code for everything that happens. It is a tiny, spinning gatekeeper to the infinite. And as we ponder this, we realize that the journey is not just about going smaller. It is about understanding how the small builds the large, how the simple builds the complex, how the ghost builds the machine. We have looked at the electron as a particle, as a wave, as a magnet, and as a celebrity in a vacuum. But what happens when electrons flow? What happens when they move in rivers? This is the story of electricity. It is the story of the nervous system. It is the story of the lightning bolt and the thought. But before we follow the river, we must pause and appreciate the drop, the single, isolated electron, a point of perfection, a speck of eternity. It does not age. It does not decay. An electron today is exactly the same as it was a microsecond after the Big Bang. It has seen the birth of galaxies. It has seen the death of suns. It has drifted through the cold nebulas and burned in the hearts of supernovas. And now it is part of you. It is reading these words. It is creating the consciousness that allows you to understand it. You are the vessel for these ancient wanderers. You are the temporary home for the eternal. And in the quiet of the night, if you listen closely enough, you might just feel the hum of their spin, the vibration of their waves, the silent, steady rhythm of the universe existing within you. The electron is a doorway. We have stepped through it into the quantum world. We have seen the vacuum foam. We have felt the Higgs field. But there are other particles in the atom. There is the heavy, dense nucleus waiting in the center of the stadium. The nucleus is a different beast entirely. It is ruled by different forces, forces far stronger and far stranger than electromagnetism. It is the realm of the quarks. It is the realm of the gluons. If the electron is a ghost, the nucleus is a fortress. And to understand the atom fully, to understand the stage on which the electron dances, we must now turn our attention to the center. We must descend from the nosebleed seats and walk onto the field. We must approach the marble. What we will find there will challenge our imagination even more than the electron did. We will find colors that are not colors. We will find forces that get stronger as you pull them apart. We will find a world where mass is created out of pure energy, not by the Higgs field, but by the sheer violence of motion. The journey inward is getting heavier. It is getting denser. We are leaving the airy cloud of the electron and entering the crushing heart of matter. We have spent a long time lingering in the outer reaches of the atom, floating in the misty, probability-clouded suburbs where the electrons live. We have watched them dance their shimmering, ghostly dance, teleporting between layers of energy, spinning without spinning, and weaving the delicate web of light and chemistry that makes up the surface of our world. But now, it is time to leave the suburbs behind. It is time to travel to the city center. It is time to cross the vast silent void that separates the electron shell from the true heart of matter. Remember our stadium analogy. If the atom is a giant sports arena and the electrons are tiny specks of dust buzzing in the highest seats, then the nucleus is a marble resting on the center spot of the field. To get there, we have to cross the pitch. In our journey, this crossing is a descent into silence and emptiness that defies comprehension. As we shrink down and move inward, leaving the electron clouds behind, we pass through a region of space that is more devoid of matter than the deepest gulfs between the stars. It is a vacuum so pure that, for a long time, we thought it was truly nothing. But as we approach the center, the feeling changes. The forces intensify. The gravity of the situation, both literally and metaphorically, begins to crush down upon us. We are approaching the nucleus. This tiny knot of matter, 100,000 times smaller than the atom itself, contains 99.9% of the atom's mass. It is unbelievably dense. If you could gather enough nuclei to fill a matchbox, that matchbox would weigh 2.5 billion tons. It would weigh as much as a mountain. It would tear through the table, through the floor, through the Earth's crust, and sink all the way to the core of the planet. This is the density of a neutron star, brought down to the microscopic scale. It is matter packed so tightly that it ceases to behave like anything we know in the macroscopic world. As we land on the surface of this marble, we are greeted by a new set of players. We find the protons and the neutrons. For a long time, just like with the atom itself, we thought these were the fundamental building blocks. We thought the proton was a hard, positive sphere, and the neutron was a hard, neutral sphere, and that they just clumped together like grapes in a bowl. It was a simple, comforting picture. But by now, you know the pattern of this story. Simplicity in physics is almost always a mask for a deeper, more chaotic complexity. The grape bunch model is a lie. The nucleus is not a bowl of fruit. It is a boiling cauldron of the most powerful force in the universe. Consider the proton. It carries a positive electric charge. We know from our time with the electrons that opposite charges attract, but like charges repel. Two positive charges hate each other. They want to push apart with violent force. Now, imagine packing dozens, or in the case of heavy elements like gold or lead, nearly 100 positive protons into a space so tiny it barely exists. The electromagnetic repulsion between them is colossal. It is screaming for the nucleus to explode. It wants to tear the atom apart. By all the laws of electricity we experience in daily life, the nucleus should not exist for even a fraction of a nanosecond. It should blow itself to pieces. So, why are you not exploding? Why is the chair beneath you stable? Why does the universe have heavy elements? The answer is that there is a monster living in the nucleus, a force so strong that it makes electromagnetism look like a gentle breeze. We call it, with typical scientific understatement, the strong nuclear force. But a better name might be the grip of God. This force is 100 times stronger than the electromagnetic force, but it has a very short reach. It only works at incredibly short distances the size of the nucleus itself. But within that range, it is absolute. It grabs the protons and neutrons and crushes them together, overcoming their hatred for each other, binding them into a tight, vibrating bundle. It is this tension, the war between the electric desire to explode and the nuclear desire to bind, that defines the energy of the atom. When you split an atom in a nuclear reactor, you are simply snipping the ropes of the strong force and letting the electric repulsion finally have its way, releasing the pent-up rage of the protons in the form of heat and light. But we are here to ask, what is inside? So we cannot stop at the proton. We must crack it open. We must look inside the marble, and when we do, when we peer into the interior of a proton, we find that the solid particle is yet another illusion. The proton is not a billiard ball. It is a bag of 3 energetic specks called quarks. The discovery of quarks in the 1960s was a revolution. It changed our understanding of matter fundamentally. We found that the proton is made of 2 up quarks and 1 down quark. The neutron is made of 1 up quark and 2 down quarks. These names, up and down, mean nothing. They are just labels, flavors chosen by physicists who ran out of Greek letters. They could have been called chocolate and vanilla or bright and dark. But up and down, they are. These quarks are the true fundamental particles of the nucleus. Like the electron, they appear to be point-like. They have no size that we can measure. But unlike the electron, they carry fractional electric charges. An up quark has a charge of plus 2/3. A down quark has a charge of minus 1/3. When you add 2 ups and a down, you get plus 1, the charge of the proton. When you add 1 up and 2 downs, you get 0, the charge of the neutron. The math works out perfectly, but the quarks are not just floating around inside the proton like marbles in a sack. They are flying. They are zooming around at speeds close to the speed of light. They are frantic, and they are held together by the strong force. But here is the strangest part of all. The strong force behaves differently than any other force we know. With gravity or electricity, the force gets weaker as you move things apart. If you move two magnets away from each other, the pull fades, but the strong force behaves like a rubber band. The further you pull two quarks apart, the stronger the force pulls them back together. It never fades. It only snaps back. This leads to a phenomenon called confinement. You can never, ever find a single quark alone in the universe. If you try to pull a quark out of a proton, if you grab it with some cosmic tweezers and pull, the rubber band of the strong force stretches and stretches. You have to put more and more energy into the pulling. Eventually, the energy stored in that stretched rubber band becomes so great that it snaps. But it doesn't just release the quark. E equals mc squared kicks in. The energy of the snap is converted into mass. It creates a new pair of quarks, a quark and an antiquark, out of thin air. One attaches to the quark you were pulling, and the other snaps back into the proton. You don't end up with a free quark. You end up with a new particle, a meson, and the proton remains sealed. Nature forbids naked quarks. They are prisoners of their own attraction. So, inside the proton, we have these three quarks buzzing around, trapped by the rubber bands of the strong force. The carrier of this force, the particle that acts as the rubber band, is called the gluon. It is the glue of the universe. Gluons are constantly being exchanged between the quarks, changing their color charge, a property that has nothing to do with visual color, but is just another way of bookkeeping the strong interaction. Quarks flicker between red, green, and blue charges, and the gluons shuttle this color back and forth, weaving a web of force that is virtually unbreakable. But here is the fact that will truly blow your mind, the fact that changes how you see your own body. We said earlier that the electron gets its mass from the Higgs field. That is true for the electron, and it is true for the quarks too. The up and down quarks have a tiny bit of mass from the Higgs, but if you add up the mass of the three quarks inside a proton, you get a number that is only about 1% of the proton's total mass. 1%. Where does the other 99% come from? It comes from the energy. It comes from the chaos. The inside of a proton is a storm. The quarks are flying at near light speed. The gluons are flashing back and forth. Virtual quark-antiquark pairs are popping in and out of the vacuum foam inside the proton, seething and boiling. All of this frantic motion, all of this binding energy, all of this tension in the gluon field, it all has energy. And as Einstein taught us, energy is mass. Mass is just trapped energy. 99% of the mass of your body, the weight you see on the scale, the heaviness of your limbs, the substance of your bones, is not stuff in the traditional sense. It is not the mass of particles. It is the kinetic energy of the gluon storm raging inside your protons. You're made of motion. You're made of light trapped in a box. You're made of pure energy, bound up by the strongest force in nature, pretending to be solid matter. Let that sink in as you lie in the quiet. You feel heavy on the bed. That heaviness is the gravity of Earth pulling on the frantic energy of your gluons. If the motion inside your atoms stopped, if the storm calmed down, you would instantly lose 99% of your weight. You would become a ghost. Your substance is a direct result of the violence of the subatomic world. The peace you feel in your macro world is built on a foundation of absolute, screaming chaos. And the gluons themselves are fascinating creatures. Unlike photons, which carry the electromagnetic force but have no charge themselves, gluons carry the color charge. They interact with each other. Photons pass through each other like ghosts. Beams of light don't bounce off each other. But gluons stick. Gluons can branch. Gluons can form clumps. There is a theoretical object called a glue ball, which is a particle made entirely of gluons, entirely of force, with no matter quarks at all. It would be a chunk of pure force field floating through space. We haven't found one yet, but the theory says they should exist. This picture of the proton, a bag of 3 quarks, is actually a simplification. It is the cartoon version. If you look with a high-energy microscope, the inside of the proton looks less like 3 distinct points and more like a roiling sea. It is a soup of quarks and antiquarks and gluons appearing and disappearing so fast that it is impossible to count them. It is called the quark-gluon plasma, or the parton sea. The 3 valence quarks, the 2 ups and 1 down, are just the excess, the net result left over when you cancel out all the matter and antimatter pairs. They are the tip of the iceberg floating on an ocean of virtual potential. So, the marble in the center of the stadium is not a static rock. It is a universe unto itself. It is a region of space where the vacuum is excited into a frenzy of creation and destruction. It is a tiny, self-contained Big Bang that never ends. And this frenzy is shielded from the outside world by the strong interaction kept confined within a radius of 1 femtometer. This confinement is what gives the nucleus its edge. It is what makes it feel hard. When you touch something, you are feeling the electron repulsion, yes, but the mass that resists your push, the inertia that makes a bowling ball hard to throw, that comes from the gluon storm. We have now journeyed from the edge of the atom to its core. We have seen the electron cloud, the vacuum cloak, and the gluon storm. We have seen that matter is a very fluid concept. It is mostly empty space, populated by point particles that are really waves, gaining their mass from interactions with fields and from the energy of their own imprisonment. But there is a pattern here. At every level, we find that what looks like a thing is actually a relationship. An electron is a relationship with the electromagnetic field. A proton is a relationship between quarks and gluons. Existence is not a set of nouns. It is a set of verbs. It is a happening. It is a process. And there is a deep, ancient connection here. The protons in your body are old, very old. Free neutrons decay in about 15 minutes. But protons are unbelievably stable. As far as we know, a proton has never decayed. We have built giant tanks of water deep underground, lined with sensors, waiting to see a single proton fall apart. We have waited for years. We have seen nothing. The lower limit for the lifetime of a proton is 10 to the power of 34 years. That is billions of trillions of times longer than the current age of the universe. This means that the protons in the water in your cells, the protons in the DNA of your genes, are the same protons that were created in the first microsecond of the universe. They are the original survivors. They have passed through stars, through supernovas, through the cold of space, through the formation of Earth, through the primordial oceans, through dinosaurs and ancestors, to reside in you today. You are the custodian of the oldest objects in existence. You are a vessel for the eternal flame of the strong nuclear force. This longevity gives us a sense of continuity in a world where everything changes, where bodies age, where civilizations rise and fall. The proton persists. It is a tiny, spinning monument to permanence. It anchors us to the beginning of time and connects us to the unimaginable future. As long as protons endure, there will be matter. There will be stars. There will be the potential for life. But even the nucleus, with all its strength and stability, is not the end of the story. There are mysteries that lie even deeper. Mysteries about why there is something rather than nothing. Mysteries about why the universe chose these specific particles and these specific forces. And mysteries about the ghostliest particle of all, the one that can pass through a light year of lead without hitting anything, the one that is streaming through your body by the trillions right now, unnoticed and unseen. This is the neutrino, the little neutral one. It is the shy cousin of the electron, and it holds clues to the hidden sectors of the cosmos. And beyond the neutrino, there is the question of unification. We have talked about the electromagnetic force and the strong nuclear force as separate titans. But physicists dream of a time in the hot first moments of the universe when these forces were one. They dream of a grand unified theory, a single equation that describes the electron, the quark, the photon, and the gluon as different facets of a single, beautiful diamond. We are not there yet, but the journey into the heart of matter is a journey toward that unity. As we prepare to leave the crushing density of the nucleus and look for these elusive neutrinos, take a moment to feel the energy trapped inside you. You are a powerhouse. If you could release the binding energy of the protons in your body, you would shine brighter than a star. You are walking around with enough energy to power a civilization for thousands of years, locked safely away in the tiny, vibrating hearts of your atoms. It is a hidden treasure, a dormant fire, and it is yours. The silence of the room is now heavy with this knowledge. The air is thick with the weight of the gluons. The world is vibrant, pulsing, alive, with a frantic, hidden motion that balances perfectly to create the peace of a quiet night. We are floating on a sea of energy, anchored by the strong force, defined by the exclusion principle, and painted by light. We have seen the fortress. Now, let us look for the ghosts that pass through the walls. Let us turn our attention to the neutrino, the particle that barely exists, the whisper of the universe. Imagine standing in a heavy rainstorm. You can feel the raindrops drumming against your skin, soaking your clothes, running down your face. You feel the pressure of the water. You feel the cold. You are an obstacle to the rain. Your body stops the drops, splashes them, diverts them. You are solid, and the rain is external. Now, imagine a different kind of rain, a rain so fine, so subtle, and so indifferent to your existence that it does not stop when it hits you. It does not splash. It does not soak. It simply passes through you as if you were made of mist. It passes through the roof of your house, through the floor, through the bedrock of the earth, through the molten core, and out the other side, continuing on into the blackness of space, without having slowed down in the slightest. This is not a fantasy. This is happening right now, in this quiet room, while you breathe, while you read. You are being bathed in a cosmic shower of ghost particles. They are called neutrinos, and to them, you do not exist. You are not solid matter. You are a vacuum with a few scattered impurities. To a neutrino, the entire Earth is just a foggy patch in empty space, barely worth noticing. The numbers involved are staggering, almost impossible to hold in the mind. Every single second, about 65 billion neutrinos pass through the size of your fingernail. If you hold up your hand to the sun, trillions of them are streaming through your palm every moment. They come from the nuclear furnace at the heart of our star. They were born in the violent fusion reactions that turn hydrogen into helium, the same reactions that create the sunlight that warms your face. But while the light has to fight its way out of the sun, bouncing around for thousands of years before it reaches the surface, the neutrinos fly straight out. They reach Earth in 8 minutes. They punch through your body, through the planet, and vanish. By the time you finish reading this sentence, more neutrinos will have passed through you than there are stars in the observable universe. And you didn't feel a thing. Why? Why are they so ghostly? Why don't they interact? The answer lies in the forces we have been exploring. We talked about the electromagnetic force, which allows electrons to touch and bond and see. Neutrinos have no electric charge. They are neutral. They are invisible to electromagnetism. They cannot see the electrons in your body, and the electrons cannot see them. They pass each other like two strangers in the dark. We talked about the strong nuclear force, the grip of God that holds quarks together. Neutrinos do not feel the strong force. They are immune to the glue of the nucleus. They glide right past the gluon storm without a tremor. The only force that the neutrino feels, other than the extremely weak tug of gravity, is the weak nuclear force. This is the fourth fundamental force, and it is the strangest of them all. It is weak, yes, but it is also incredibly short range. For a neutrino to interact with an atom, it has to hit the nucleus dead on, within a distance so tiny it makes the atom look like a galaxy. The chances of this happening are astronomically low. A neutrino could travel through a block of solid lead, that is 1 light-year thick, about 6 trillion miles of lead, and still have a 50-50 chance of coming out the other side without hitting a single atom. That is how lonely the neutrino is. That is how vast the space between particles really is. The story of the neutrino's discovery is a story of faith in the laws of physics. In the 1930s, physicists were studying a type of radioactive decay called beta decay. A neutron would turn into a proton and spit out an electron. But when they measured the energy, something was missing. The energy before the decay didn't equal the energy after. It seemed like energy was simply disappearing from the universe. This was a crisis. The law of conservation of energy is sacred. You cannot just lose energy. Some physicists were ready to give up the law, but Wolfgang Pauli, the man of the exclusion principle, had a different idea. He suggested that maybe, just maybe, there was a third particle coming out of the decay, a particle that was invisible, massless, and neutral, carrying away the missing energy like a thief in the night. He called it a desperate remedy. He thought he had proposed a particle that could never be detected. The Italian physicist Enrico Fermi gave it the name neutrino, Italian for little neutral one, and for 25 years it remained a ghost story, a mathematical fiction to save the books. But in 1956, we finally caught one. We built a detector near a nuclear reactor, a place where neutrinos are made in huge numbers, and we waited. And we saw the tiny, rare flashes of interaction. The ghost was real. But how do you catch a ghost? How do you study something that can pass through a planet? You build a trap made of silence and water. Deep underground in the mountains of Japan, there is a cathedral of science called Super Kamiokande. It is a cylindrical tank, 10 stories tall, buried a kilometer beneath the rock to shield it from cosmic rays and other noise. It is filled with 50,000 tons of ultra-pure water, water so clean that it acts like a perfect lens. Lining the walls of this tank are 11,000 golden glass bulbs, photomultiplier tubes, that look like giant, unblinking eyes staring into the dark. The scientists wait. They wait for that 1 in a trillion chance that a neutrino, flying through the Earth, will slam head-on into an electron or a nucleus in the water. When that happens, the collision creates a tiny shock wave, a boom, but not a boom of sound, a boom of light. The particle released by the collision moves through the water faster than light can move through water. Nothing moves faster than light in a vacuum, but light slows down in water. Particles can beat it. This creates a cone of eerie, beautiful blue light called Cherenkov radiation. It is the optical equivalent of a sonic boom. The golden eyes on the walls see this faint blue ring flash in the darkness, and from the shape and timing of that ring, the scientists can reconstruct the path of the ghost. They can tell where it came from. They can tell if it came from the sun, or from the atmosphere, or from a supernova exploding in a distant galaxy. Imagine sitting in a boat on that dark, underground lake. It is utterly silent. The water is still. You are buried under a mountain. And yet, every once in a while, a flash of blue light erupts in the depths, signaling the arrival of a messenger from the core of a star. It is a profound connection. That blue light is the final gasp of a particle that was born in the nuclear fire of the sun, traveled 93 million miles, passed through the rock of the Japanese Alps, and finally decided to stop and say hello. These detectors have revealed that neutrinos are not just one thing. They come in 3 flavors: the electron neutrino, the muon neutrino, and the tau neutrino. And they have a secret that shocked the world. They change. As a neutrino travels through space, it morphs from one flavor to another. It oscillates. An electron neutrino born in the sun might arrive at Earth as a muon neutrino. It is as if you threw an apple in the air, and it turned into an orange before you caught it. This oscillation implies something monumental. For a particle to experience time, for it to change, it cannot travel at the speed of light. It must travel slightly, ever so slightly, slower. And if it travels slower than light, it must have mass. For decades, we thought neutrinos were massless, like photons. Now we know they have a tiny, tiny sliver of mass, millions of times lighter than an electron, but not zero. This tiny mass changes our understanding of the universe. Because there are so many neutrinos, billions for every atom in the cosmos, that tiny mass adds up. They contribute to the gravity of the universe. They affect how galaxies form. They are the dust that tips the scales of cosmic evolution. The nothing particles are actually shaping the everything. And there is another mystery, perhaps the deepest of all. Neutrinos are left-handed. In the quantum world, particles have a property called chirality, which relates to their spin. Most particles can be left-handed or right-handed, but every neutrino we have ever seen is left-handed. If you look in a mirror, a left hand looks like a right hand, but if you look at a neutrino in a mirror, you see a right-handed neutrino, and right-handed neutrinos do not seem to exist, or at least they don't interact with our world. This means the universe is not perfectly symmetrical. The mirror is broken. The weak force, the force that governs neutrinos, is the only force that cares about left and right. It distinguishes. It has a preference. Why? We do not know. It is a crack in the perfection of nature's geometry. It hints that there might be more to the story. Perhaps there are right-handed neutrinos that are even ghostlier, so heavy and so silent that they are what we call dark matter. Perhaps the neutrino is the bridge to a hidden sector of reality, a shadow universe that sits right on top of ours, but never touches it. As you lie there, feeling the solidity of the bed and the warmth of the air, remember the neutrinos. Let your mind become transparent. Visualize the trillions of tiny sparks streaming through the roof, through your body, through the bed, plunging deep into the earth. You are not a wall to them. You are a mist. You are a lattice of widely spaced atoms in a vast void, and the universe flows through you like wind through a wire fence. This transparency connects you to the cosmos in a way that light never could. Light bounces off your skin. It shows you the surface of things. But neutrinos pass through the core. They carry information from the deep, hidden places. They bring us news from the center of the sun, where the fusion fires burn. They bring us news from the hearts of dying stars. In 1987, a star exploded in the Large Magellanic Cloud, a neighbor galaxy to the Milky Way. It was a supernova, a cataclysmic death that outshone its entire galaxy. Before the light of the explosion reached us, the neutrinos arrived. A burst of them washed over the Earth. Our detectors, primitive as they were back then, caught just a handful, about 24. But those 24 specks of data confirmed our theories of how stars die. When a massive star collapses, it crushes its own core into a neutron star, and in that crushing, it releases a tsunami of neutrinos. The star literally cools itself by sweating neutrinos. 99% of the energy of a supernova is released not as light, but as this invisible wind. The visible explosion, the spectacular firework that astronomers see, is just the 1% aftershock. The real event is the neutrino burst. So, when a star dies, it breathes out a ghost, and that ghost breath flows through the universe, touching everything, passing through everything, connecting the death of a giant to the water in a tank in Japan, and to the cells in your body. You have undoubtedly been touched by neutrinos from exploding stars that died before the dinosaurs evolved. You are a silent witness to the most violent events in history. This realization brings a strange kind of peace. We often feel isolated, trapped in our own heads, separate from the world. But physics tells us there is no separation. We are permeable. We are open systems. The matter of the universe, the forces of the universe, and the particles of the universe are in constant commerce with us. We are swimming in a sea of neutrinos, a sea of fields, a sea of light. We are not islands. We are waves in the ocean. And the neutrino teaches us humility. It reminds us that our senses are limited. We evolved to see light because light bounces off things and helps us find food and avoid danger. We did not evolve to see neutrinos because they don't do anything to us. But just because we cannot feel them doesn't mean they aren't there. It doesn't mean they aren't important. It suggests that reality is much, much richer than our human experience can ever encompass. There are layers of existence, entire symphonies of particles playing right here in this room that we are completely deaf to. Science is the hearing aid that allows us to listen to the silent music. What else is passing through us? What other ghosts haunt the room? We know about dark matter. We know it makes up 85% of the matter in the universe. It is out there, holding the galaxies together, spinning the web of the cosmos. Is it made of heavy neutrinos? Is it made of axions? Is it passing through you right now, just as silent and indifferent as the neutrino? Probably. You are likely sitting in a wind of dark matter, a flow of substance that outweighs all the stars and planets combined, and you cannot feel a whisper of it. The electron gave us touch, the photon gave us sight, the quark gave us mass, but the neutrino gives us the unknown. It gives us the mystery. It stands at the edge of our knowledge and points into the dark. It tells us that the empty space is full of secrets. As we let the idea of the neutrino settle, as we accept our own transparency, the room feels larger. The walls are not boundaries anymore. They are just shadows in the neutrino stream. The Earth is not a solid rock. It is a cloud. The sun is not just a ball of light. It is a nuclear reactor humming in the neutrino spectrum. We are seeing with new eyes. We are feeling with a new sense, the sense of imagination guided by truth. And this journey inward, past the electron, past the nucleus, through the ghost stream, leads us to a fundamental question. We have talked about particles as if they are tiny things, but we have also hinted that they are waves, vibrations, excitations. What is the medium? What is vibrating? If you take away the particles, what is left? We are now ready to confront the bedrock of reality. We are ready to talk about quantum field theory. We are ready to see that the universe is not made of stuff at all. It is made of fields, fluid, dynamic, everlasting fields that stretch from infinity to infinity. The electron is just a ripple in the electron field. The neutrino is a ripple in the neutrino field. You are a collection of ripples. You are a disturbance in the smooth surface of space-time. The transition from particle to field is the final shedding of the old mechanical worldview. It is the move to a universe that is more like an ocean than a clock. And as we descend into the fields, we will find that even the vacuum, the empty void we thought we understood, is alive with potential. We will find that nothing is unstable. We will find that everything we are is just a temporary loan from the vacuum bank. So, let the neutrinos pass. Let them fly through you on their way to eternity. They are the silent messengers of the weak force, reminding us that strength does not always mean solidity. Sometimes the most powerful things are the ones that leave no trace. Sometimes the deepest truths are the ones that slip through our fingers. We are drifting deeper now. The particles are fading into waves. The distinct points are melting into continuous sheets of energy. We are approaching the level where the universe is simply a set of vibrating strings, a set of harmonic oscillators, a set of fields singing to themselves in the dark. We are going to listen to the song of the fields. We are going to learn what it means to be a ripple. If you look at a calm lake on a windless day, the surface is a perfect mirror. It reflects the sky, the clouds, the trees. It looks empty, it looks flat. But if you toss a single pebble into the center of that lake, suddenly the water comes alive. A ripple spreads out, a perfect circle of motion traveling across the surface. Now ask yourself, what is the ripple made of? Is it a thing? Is it a separate object that you can pick up and put in your pocket? No. The ripple is made of water. It is just the water behaving in a specific way. It is an excitation of the lake. The water was there before the ripple, and it will be there after the ripple is gone. The ripple is a temporary event in a permanent medium. Now, take this image and expand it until it swallows the entire universe. This is the deepest secret of modern physics. There are no particles. There are no tiny balls. There are no solid specks of matter. There are only fields. There are only lakes. And you and the chair and the stars and the galaxies are just the ripples. We are now entering the realm of quantum field theory. It is a place where the distinction between object and space completely dissolves. We are used to thinking of the universe as a box, a container that is filled with stuff. In this old way of thinking, if you took all the stuff out, all the atoms, all the light, all the stars, you would be left with an empty container, a void. But quantum field theory tells us that the container is the stuff. The universe is filled from corner to corner with invisible, fluid-like fields. There is an electron field that stretches from your heart to the edge of the cosmos. There is a quark field that permeates every inch of space. There is a photon field, a neutrino field, a gluon field. These fields are everywhere, all the time. They are the fundamental reality. When we say, there is an electron here, what we really mean is, there is a ripple in the electron field here. When we say, an electron moves, we mean the ripple is propagating through the field, just like a wave moving across the ocean. The water molecules don't travel from the middle of the ocean to the shore. The energy travels. The form travels. In the same way, the electron is not a little traveler journeying through a void. It is a disturbance passing through a medium. This changes everything about how we see ourselves. We tend to think of ourselves as isolated islands of matter, separate from the air around us, separate from the ground, separate from each other. But if you are made of ripples in fields that extend infinitely, then you are not separate at all. The electron field that is waving to create the atoms in your hand is the exact same field that is waving to create the atoms in the wall, and the atoms in the moon, and the atoms in a star a billion light years away. It is one single, continuous sheet of reality. You are just a local knot in a universal fabric. This realization is profoundly meditative. It means that at the most fundamental level, there is no empty space between us. The space between your eye and this screen is not empty. It is filled with the electromagnetic field, the electron field, the Higgs field, all humming quietly in their lowest energy state. When you reach out to touch someone, you're not bridging a gap. You're creating an interaction within a medium that already connects you. We are all waves on the same ocean. We are all songs sung by the same voice. Let's go deeper into this ocean. If the fields are the water, what is the vacuum? What is nothing? In classical physics, the vacuum was just zero. Zero energy, zero matter, zero everything. But in quantum field theory, the vacuum is alive. It is the fields in their quietest state. But because of the laws of quantum mechanics, specifically that uncertainty principle we keep meeting, a field can never be perfectly still. It can never have exactly zero energy. If the energy were exactly zero and the field was perfectly flat, we would know both its value and its rate of change with infinite precision, which is forbidden. So, the fields must jitter. They must tremble. Even in the absolute frozen dark of deep space, every single field is vibrating with a tiny, irreducible amount of energy. This is called the zero-point energy. The vacuum is seething with it. It is a roiling froth of quantum fluctuations. Picture the surface of the ocean again. Even on the calmest day, there are tiny molecular vibrations, microscopic shudders. The vacuum is like that. It is boiling with virtual particles popping in and out of existence, borrowing energy from the field and paying it back endlessly, everywhere, forever. This means that you are not just walking through air. You are walking through a storm of invisible activity. Every cubic centimeter of empty space in your room contains enough zero-point energy to potentially boil all the oceans on Earth. If only we could access it. But we cannot. It is the baseline. It is the ground floor of existence. We float on top of this energy like boats on a deep sea. We are unaware of the depth, unaware of the power beneath us, but it is there. It holds us up. This concept of fields resolves the mystery of how particles are identical. We asked earlier why every electron is exactly the same as every other electron. If they were made in a factory, you would expect tiny differences, a scratch here, a dent there, a slight variation in weight. But electrons are absolutely identical. Why? Because they are not made in a factory. They are made of the same stuff. They are all ripples in the same field. Two ripples on a pond are identical because they are both just water obeying the same laws of physics. Two electrons are identical because they are both just the electron field obeying the same equation. There is only one electron field in the universe. We are all made of the same ingredient. And this leads to a beautiful possibility: transience. A ripple can die. A wave can crash on the shore and vanish, its energy dissipating back into the water. Particles can be created and destroyed. In the old physics, matter was eternal. You couldn't create or destroy an atom. But in the new physics, matter is just a temporary excitation. When an electron meets a positron, they annihilate. The ripples cancel each other out. The water goes flat. The energy is released as a splash of photons, but the stuff of the electron is gone. It has returned to the field. This suggests that our existence is a flow. We are not statues made of marble. We are waterfalls. A waterfall looks like a solid object. It has a shape. It stays in the same place. But the water inside it is constantly changing. New water flows in. Old water flows out. The waterfall is a pattern, not a thing. You are a pattern. The carbon atoms in your body today are not the same carbon atoms that were there 10 years ago. You are constantly exchanging matter with your environment. You are a standing wave in the quantum fields, a localized storm that persists even as the wind blows through it. So, what is inside the electron? The field is inside. The potential for everything is inside. The electron is just a pinched-up bundle of the universe's possibility. And there are so many fields. The standard model of particle physics, our best map of reality, lists 17 fundamental particles. That means there are at least 17 fundamental fields layered on top of each other, occupying the same space, vibrating in harmony. There is the electron field, the neutrino fields, the quark fields, the photon field, the gluon field, the W and Z boson fields, and the Higgs field. They are all right here, right now, ghosting through each other. Imagine a music room. You have a piano, a cello, a violin, a flute. They are all playing different notes. The sound waves fill the room. At any single point in the air, the pressure is vibrating in a complex way that is the sum of all those instruments. The air is one medium carrying many songs. Space is like that. It is carrying the electron song, the quark song, the photon song, all at once. And where the songs intersect, where the harmonies align, that is where we perceive matter. That is where we perceive events. When an electron emits a photon, it is not one little ball spitting out another little ball. It is the electron field transferring energy to the photon field. It is a modulation. Like a violin string vibrating and causing a nearby piano string to hum sympathetically. The fields talk to each other. They couple. The mathematical term is coupling. The electron field is coupled to the electromagnetic field. They are friends. They exchange energy. The neutrino field, as we learned, is not coupled to the electromagnetic field. It ignores it. It plays a different tune that the photon field cannot hear. This field view explains the spooky action at a distance that Einstein worried about. Entanglement. Two particles can be linked across vast distances, reacting instantly to each other. If they were little balls, this would be magic. But if they are ripples in the same continuous field, it is less mysterious. They are part of the same wave function. They are connected by the fabric itself. The distance between them is measured in the field, and the field knows what is happening everywhere at once. Let us return to the Higgs field, because in this context, it becomes even more fascinating. We said it was like molasses. In field theory, we say the Higgs field has a non-zero vacuum expectation value. That is a mouthful of jargon, but it means something poetic. The Higgs field is not zero, even when it is empty. Most fields, like the electron field, are zero on average until you add energy to make a ripple. But the Higgs field is on everywhere, all the time. It is like a switch that is stuck in the up position across the entire universe, because it is always on. Other particles have to wade through it constantly. They cannot escape it. If the Higgs field turned off, if it dropped to zero like the other fields, suddenly the electron would stop feeling that drag. It would lose its mass. You would vaporize. The stability of your body depends on this one specific field holding its value, keeping the cosmic switch flipped to on. Why is it on? Why does it have this value? We don't know. It is one of the arbitrary constants of nature that allows us to exist. We are balanced on a knife edge of quantum probability. As you lie in the dark, imagine these layers. Visualize the space around you not as emptiness, but as a thick, rich tapestry of vibrating energy. You are wrapped in blankets of fields. You are woven into the cosmos. There is no outside. You cannot go outside the universe because the fields are the universe. Wherever you go, you take the fields with you. You are a local modulation of the infinite. This perspective can heal the sense of loneliness that comes with the scientific worldview. We are often told that science creates a cold, mechanical world, but quantum field theory is not mechanical. It is organic. It is fluid. It is interconnected. It tells us that we are continuous with the stars. The boundaries we see, skin, air, wall, world, are just changes in the intensity of the fields. They are not real separations. The quiet hum of the room is the hum of the zero-point energy. The darkness is a canvas painted with invisible light. You are safe in this ocean. You have been floating in it for billions of years in one form or another, and you will float in it forever. The energy that makes you up cannot be destroyed. It can only return to the field to become a new ripple, a new song, a new star. But there is a force we haven't talked about much yet. We have talked about the strong force, the weak force, and electromagnetism. These are all described perfectly by quantum field theory. They are all exchanges of particles, gluons, W and Z bosons, photons. They fit into the picture of fields talking to fields. But there is one force that refuses to fit, one force that stands apart, stubborn and ancient. The force that is holding you to the bed right now. Gravity. Gravity is the outlier. It is the rebel. When we try to write a quantum field theory for gravity, the math breaks. It yields infinities. It talks nonsense. Gravity does not seem to be just another field living in space. Gravity seems to be the shape of space itself. This brings us to the edge of human knowledge. It brings us to the conflict between the smooth, curving world of Einstein and the jagged, jittery world of the quantum. What is inside the electron? We have found mass, charge, spin, fields, vacuum foam, and interaction. But does the electron feel gravity? Yes. It has mass. It curves space-time. Tiny as it is, an electron pulls on the entire universe, and the universe pulls back. But how? Does the electron emit gravitons? Is there a gravity field? Or is something else going on? As we prepare to ponder the mystery of gravity, let us rest in the certainty of the fields. Feel the fluidity of your own existence. You are not a machine. You are a process, a beautiful, complex, self-sustaining wave of awareness flowing through the quantum ocean. The universe is soft. It is vibrating. It is listening. And in the next chapter, we will ask how this soft, vibrating universe creates the crushing, absolute law of gravity. We will ask if the electron might be a tiny black hole. We will look at the edge of the known and peer into the abyss where our theories fall apart. Because it is in the breakdown of our knowledge that the true wonder hides. The journey continues from the ripple to the wave, from the wave to the ocean, and now from the ocean to the geometry of the container itself. We have arrived at the edge of the map. In our journey into the electron, we have navigated the swirling clouds of probability. We have sailed the seething ocean of the vacuum, and we have listened to the silent harmonies of the quantum fields. We have built a picture of the universe that is fluid, dynamic, and interconnected. But there is one force we have left lingering in the background, a force that you are feeling right now in the most intimate way possible. It is the force that pulls your back against the mattress. It is the force that makes your eyelids heavy. It is the force that holds the atmosphere to the earth and the earth to the sun. It is gravity. And when we try to bring gravity down into the microscopic world of the electron, something catastrophic happens to our understanding. The map tears. The compass spins wildly. The smooth, beautiful laws of physics crash into each other and break. To understand this catastrophe, we have to look at the electron not as a cloud of charge, but as a speck of mass. We know it has mass. It is a tiny amount, so small that if you wrote it out in kilograms, you would need 30 zeros after the decimal point. But it is there, and Einstein taught us, in his magnificent theory of general relativity, that mass tells space how to curve, and curved space tells mass how to move. Imagine a heavy bowling ball placed on a trampoline. It curves the fabric downwards. If you roll a marble nearby, it will circle the bowling ball, following the curve. That is gravity. It is not a magical pull. It is geometry. It is the shape of the container. Now, place an electron on that trampoline. The electron is not a bowling ball. It is a point. It has zero size. In mathematics, if you take even a tiny amount of mass and squeeze it into zero volume, the density becomes infinite. It becomes a singularity. On the fabric of space-time, the electron should not just make a gentle dip. It should puncture the fabric. It should create a bottomless pit. According to the strict rules of general relativity, every single electron in your body should be a black hole. This is the great paradox. If electrons were black holes, the universe would be a nightmare of event horizons. We would be swallowed up. But electrons are stable. They are gentle. They build flowers and raindrops, not singularities. So, either general relativity is wrong at small scales, or our understanding of the electron as a point is wrong, or something strange is happening to gravity when it gets that small. The conflict arises because gravity is a smooth theory. It loves curves. It loves continuity. It describes the universe as a polished sheet of silk. Quantum mechanics, the ruler of the electron, is a chunky theory. It loves steps. It loves jumps. It describes the universe as a pixelated grid. When you try to combine them, when you try to calculate the gravitational pull of a quantum particle, the math explodes. It gives you answers of infinity everywhere. You cannot have infinite gravity in a finite universe. This breakdown tells us that deep inside the electron, there is a secret layer of reality where space and time themselves might dissolve. Let us pause and consider the sheer weakness of gravity. This is one of the deepest mysteries in physics, known as the hierarchy problem. Think about a simple refrigerator magnet. It is a small piece of metal, maybe the size of a coin. You hold it over a paperclip. The entire Earth, all 6 septillion kilograms of rock, iron, and magma, is pulling that paperclip down. The gravity of an entire planet is grabbing it. But the tiny magnet, with its weak little magnetic field, pulls the paperclip up. It wins. A coin-sized magnet defeats an entire planet. That is how weak gravity is compared to the electromagnetic force. It is trillions upon trillions of times weaker. Why? Why is gravity so faint? Why is the force that moves galaxies so shy when it meets an electron? Some physicists believe that gravity is leaking. They suggest that our universe might have more than 3 spatial dimensions. Maybe there are 4th, 5th, 6th dimensions curled up so tightly that we cannot see them. Gravity might be the only force that can travel through these extra dimensions. While the electron and the photon are stuck on the 3-dimensional surface of our world, gravity might be drifting off into the bulk, diluting its strength. If this is true, then inside the electron, right at that point of infinite density, there might be a doorway to higher dimensions. The electron might be a pin holding the layers of the multiverse together. There is a fascinating theory that tries to resolve the black hole paradox. It suggests that the electron is a black hole, but a special kind. It is a charged black hole. In Einstein's equations, mass pulls space in, but electric charge pushes it out. If you have enough charge packed into a small enough space, the repulsive force can balance the gravitational pull. This creates a naked singularity, a point of infinite density that doesn't have an event horizon around it. It is a star that has collapsed, but hasn't gone dark. This solution is called the Reissner-Nordstrom metric. It is a beautiful mathematical object. Is the electron a tiny, naked singularity, balanced perfectly between the desire to collapse and the desire to explode? If it is, then the inside of an electron is a place where time stops. At a singularity, the concepts of before and after lose their meaning. Cause and effect break down. It is a timeless, spaceless point, and you are made of these points. You are built out of trillions of tiny knots where time stands still. This suggests that the flow of time you experience, the ticking of the clock, the beating of your heart, is an emergent property. It is something that happens between the electrons, not inside them. Time is a collective hallucination of the macro world. But nature abhors a singularity. Infinities usually mean we are missing something. This brings us to the most famous attempt to fix the broken map, string theory. We touched on this earlier, but now we must embrace it fully. String theory says, stop trying to make the electron a point. Points are dangerous. Points make holes. Instead, imagine the electron is a loop, a tiny vibrating rubber band of pure energy. It is unfathomably small, the Planck length, but it is not zero. Because it has size, it spreads its mass out. It doesn't punch a hole in space. It just indents it gently. In this view, gravity is just one of the vibration modes of the string. If the string vibrates one way, it is an electron. If it vibrates another way, it is a graviton, the theoretical particle of gravity. This unifies everything. It says that matter and gravity are just different songs played on the same strings. It heals the rift between Einstein and quantum mechanics. But it comes with a price. For the math of string theory to work, the strings need room to vibrate. They need more directions than up-down, left-right, and forward-backward. They need 10 or 11 dimensions. So, if string theory is right, every electron in your body is actually a multi-dimensional object. It is vibrating in directions that your mind cannot even conceive. You are a 10-dimensional being, but your consciousness is trapped in a 3-dimensional slice. The inside of the electron is a kaleidoscope of hidden geometries, curled up like tiny origami shapes at every point in space. These shapes are called Calabi-Yau manifolds. They are complex 6-dimensional knots that determine the properties of our universe. The reason an electron has the mass it does, the reason it has the charge it does, might be determined by the shape of this hidden knot. We are living in a universe of geometry. This feels abstract, I know, but bring it back to the feeling of weight. Bring it back to the bed. That heaviness you feel is the earth calling out to the energy trapped in your strings. It is a communication between the geometry of the planet and the geometry of your atoms. It is a whisper across dimensions. And notice how constant it is. Gravity never turns off. You can shield electricity. You can stand in a Faraday cage and block out radio waves. You can block light, but you cannot block gravity. It passes through everything. It connects everything. It is the ultimate background. Perhaps the most poetic idea about gravity and the electron comes from the concept of entanglement entropy. Some modern physicists suspect that gravity is not a fundamental force at all. They think it might be an illusion created by quantum entanglement. When two particles are entangled, they share information. The more entangled they are, the closer they are in space. In this view, space itself is stitched together by the threads of entanglement. The electron is not just a particle in space. It is a weaver of space. By interacting with other particles, by becoming entangled with them, it knits the fabric of the universe. Gravity is just the tension in that fabric. If this is true, then falling is just the natural tendency of the universe to maximize its entanglement, to increase its connection. You are held to the earth because your atoms are deeply, profoundly entangled with the atoms of the planet. You are not being pulled down. You are being merged. You are sticking to the earth because, on a quantum level, you are part of the earth. This dissolves the barrier between you and the world even further. We have already seen that you are made of the same fields. Now we see that your position in space, your very here-ness, is defined by your quantum relationships. If you were truly alone, if you were not entangled with anything, you wouldn't be anywhere. You would float off into a void of non-existence. Connection is what places us. Love, in a metaphorical sense, is gravity. It is the force that binds. Let us look at the black hole electron idea one more time. There is a concept called the gluon, proposed by John Archibald Wheeler. He imagined a ball of gravitational and electromagnetic waves held together by their own energy, a self-sustaining knot of field lines. He thought maybe particles were just these knots. It is a beautiful image. The electron as a tiny storm of light and gravity, spinning so fast it holds itself together. It suggests that matter is made of light. Not just that it interacts with light, but that it is light, folded over on itself, trapped in a gravitational embrace. Matter is frozen light, as the saying goes. If you are frozen light, then the darkness of the electron's interior is actually a blinding brilliance. It is energy so concentrated that it wraps space around it like a cloak. We are beings of light, hidden in shells of geometry. And what about the future? We know that black holes evaporate. Stephen Hawking taught us that they radiate energy and slowly shrink until they vanish. If the electron is a tiny black hole, why doesn't it evaporate? Why is it stable? Maybe it is the ground state of a black hole, the smallest possible nugget of space-time that cannot get any smaller. Maybe It is the ash left over from the evaporation of something larger. Or maybe, just maybe, it is waiting. Protons are stable. Electrons are stable. But are they eternal? Some theories suggest that eventually, in the unimaginable future, even electrons might decay. Or the vacuum itself might change, wiping them out. But for now, they are the rocks of the universe. They are the constants. They endure gravity. They endure electromagnetism. They endure the violent collisions of stars. As you lie there, feeling the gentle tug of the earth, try to visualize the electron not as a problem, but as a miracle. It is a tiny object that manages to balance the infinite forces of the universe. It balances the expansive push of charge against the crushing pull of gravity. It balances the wild jitter of quantum uncertainty against the smooth curve of relativity. It is a master of balance, and because it is balanced, you can exist. You can have a stable body in a chaotic cosmos. The mystery of gravity inside the electron is the mystery of the boundary. It is where the known world ends. We have excellent math for the atom, quantum mechanics. We have excellent math for the stars, general relativity. But right there, in the center of the electron, the two math books contradict each other. They scream different answers, and nature silently, effortlessly, resolves the contradiction. The electron simply is. It doesn't care about our math. It exists in the unity that we are trying so hard to find. It knows the answer. We are like children trying to listen to a conversation between two giants, gravity and quanta. They are speaking a language we don't speak yet. We catch a word here, a word there, string, loop, dimension, entanglement. But the full sentence eludes us, and that is okay. The mystery is what drives us. The mystery is the lullaby. The room is quiet. The gravity is constant. The electrons in your body are spinning their 10-dimensional pirouettes, stitching you into the fabric of the earth. You are heavy with mystery. You are anchored by the unknown. We have explored the particle, the wave, the field, and the heavy distortion of space. But there is one more layer to unwrap, a layer that feels less like physics and more like philosophy, yet is becoming central to modern science. It is the idea that the universe is not made of matter, nor energy, nor fields, but of information. The it-from-bit theory. Is the electron just a bit of code? Is the universe a computer? And if so, who is the programmer? Or, more importantly, who is the observer? The electron changes when we watch it. This is the most famous and unsettling fact in quantum physics. The double-slit experiment, the collapse of the wave function. The universe seems to know when we are looking. Does the electron have a primitive form of awareness? Does it respond to consciousness? The journey into the electron is about to turn inward in a new way. We are going to look at the mirror. We are going to ask, what role do you play in the existence of the electron? Are you just a spectator? Or are you the creator of reality? The gravity holds us down, but the question lifts us up. Let us prepare to enter the hall of mirrors. Let us prepare to ask if the electron is real when no one is looking. There is a room in the house of physics that most people are afraid to enter. It is a room where the solid rules of the everyday world don't just bend, they shatter. It is the room where we keep the mirrors. In our journey into the electron so far, we have treated it as an object. A very strange object, yes, a ghostly, wave-like, spinning, cloud-wrapped object. But still an object that exists out there, independent of us. We have assumed that the electron is doing its dance, whether we are watching it or not. We have assumed that the universe is a play that continues even when the audience has gone home. But there is an experiment, a simple, elegant, and terrifying experiment, that suggests this might be wrong. It suggests that the electron is not a thing until we look at it. It suggests that you, the observer, are not just watching the play. You are writing it. This is the mystery of the double-slit experiment, and it opens the door to the idea that the universe is made not of matter, but of information. That the electron is not a it, but a bit. Imagine a dark laboratory. In the center, there is a device that fires electrons one by one, like a tiny machine gun. In front of this gun, there is a barrier with two narrow slits cut into it. And behind that barrier, there is a detector screen that lights up whenever an electron hits it. If you were firing tiny bullets, little solid balls of matter, you would expect to see two bands of hits on the back screen directly behind the two slits. The bullets would go through the left slit or the right slit and pile up in two neat lines. This is what common sense demands. This is what the classical world predicts. But when we fire electrons, something magical happens. Instead of two bands, we see a complex pattern of many bands: bright stripe, dark stripe, bright stripe, dark stripe. It is an interference pattern. It is exactly the pattern you would get if you pushed water through the slits. The waves would ripple out, overlap, and where the crests met, they would get bigger, and where a crest met a trough, they would cancel out. This tells us, as we learned earlier, that the electron is a wave. It is going through both slits at the same time. It is interfering with itself. A single electron leaves the gun, splits into two ghostly possibilities, passes through both doors, dances with itself on the other side, and then decides where to land on the screen. It is a beautiful demonstration of the wave nature of matter. But here is the twist. Here is the moment where reality cracks. Physicists, being curious creatures, decided they wanted to see which slit the electron really went through. They wanted to peek. So they placed a tiny sensor, a delicate measuring device, right next to the slits. This sensor would beep very quietly if the electron went through the left slit, and boop if it went through the right. They didn't touch the electron. They didn't stop it. They just watched. And the moment they turned on the sensor, the pattern changed. The interference bands vanished. The beautiful, complex ripples disappeared. Instead, the electrons piled up in two boring, solid clumps, just like bullets, just like rocks. By the simple act of looking, the wave collapsed. The electron stopped behaving like a ghost and started behaving like a particle. It snapped to attention. It picked a side. It is as if the universe said, "Oh, you are watching. I had better behave normally." This is the measurement problem. It implies that the electron does not have a definite path until we force it to choose one. Before the measurement, the electron is in a superposition of left and right. It is a cloud of probability. After the measurement, it is a single, hard fact. This leads us to a profound question. What is an electron when no one is looking? Does it exist at all? Or is it just a question waiting for an answer? The legendary physicist John Archibald Wheeler proposed a concept he called it from bit. He suggested that at the very bottom of reality, beneath the fields, beneath the strings, beneath the space and time, there is only information. Binary code, yes or no, up or down, here or there. He argued that every particle, every force, every interaction in the universe is essentially the answer to a yes-no question posed by the observer. The electron isn't a tiny ball of stuff. It is a bit of information processing. When we measure its spin, we are asking, Are you spin up? And the universe answers yes or no. When we measure its position, we are asking, are you here? And the universe computes the answer. Think about a video game. When you are playing a game, the computer does not render the entire world at once. It only renders the room you are standing in. The mountains in the distance are just a flat image until you walk towards them. The room behind you doesn't exist. It is just code on a hard drive waiting to be called up. Is our universe a similar kind of system? Is the electron just a potentiality that gets rendered into reality only when consciousness, or at least a measurement apparatus, interacts with it? This is not science fiction. This is a legitimate interpretation of quantum mechanics. It suggests that the world is efficient. It doesn't waste energy being real where no one is looking. It stays in a state of fuzzy, wave-like probability until a witness arrives to pin it down. This view transforms the electron from a building block into a symbol. It is a letter in a cosmic alphabet. And you, the observer, are the reader. Or perhaps you are the writer. This relationship is what Wheeler called the participatory universe. He believed that the universe is not a clockwork machine that was wound up and left to run. He believed it is a self-excited circuit. The universe creates observers, us, and by observing the universe, we bring it into reality. We grant it existence. We are looking at the electron, and the electron is looking back. And in that mutual gaze, the world is born. Let this idea settle in the silence of your room. Look at the wall. Is it really there? Or is it there because you're looking at it? Is the chair beneath you solid because you are feeling it? The physics says that until an interaction occurs, the properties of these objects are not fixed. They are hovering in a haze of quantum uncertainty. Your presence, your senses, your consciousness are the needles that knit the wool of the quantum world into the sweater of reality. You are essential. You are not a tiny, insignificant speck in a vast and different cosmos. You are the reason the cosmos has a shape at all. Without you, or beings like you, the universe might just be a swirling gray fog of overlapping waves, a song with no one to hear it, a story with no one to read it. This informational view of the electron helps explain some of its strangest properties. Take entanglement again. We talked about how two particles can be linked across light years. If they are physical objects, this requires faster-than-light travel, which is impossible. But if they are just bits of information in a cosmic dataset, distance doesn't matter. In a computer memory address Orbital 1 and memory address 999 are right next to each other in the logic of the processor, even if they are physically apart on the chip. If the universe is a web of information, then space is just a way of organizing the data. Two entangled electrons are simply part of the same data structure. When you update one, the other updates instantly because they are not two things. They are two pointers to the same underlying reality. This leads us to the holographic principle. Some physicists, studying black holes and information theory, have proposed that our entire three-dimensional universe might be a projection, a hologram, generated from a two-dimensional surface at the edge of the cosmos. Imagine a soup can. The label on the outside is two-dimensional. It contains information, text, pictures, barcodes. But that information describes the three-dimensional soup inside. The holographic principle suggests that all the information that makes up you, the Earth, and the stars is actually written on the boundary of the universe. And what we experience as 3D reality is just the projection of that data. In this dizzying vision, the electron is a pixel in the hologram. It feels real. It feels round. It has depth. But its true nature is a flat bit of data encoded on the cosmic horizon. It from bit. The rock comes from the question. The reality comes from the information. This makes the electron feel less like a ghost and more like a thought. It is a thought in the mind of nature. And because you are a thinking being, you are intimately connected to this level of reality. Your brain, with its firing neurons and flowing ions, is an information processing machine. It is a quantum computer of sorts, navigating the probability clouds, collapsing wave functions into ideas, into memories, into dreams. When you think about an electron, it is information contemplating information. It is the code reading itself. There is a deep peace in this perspective. It removes the heaviness of the material world. We often feel burdened by the weight of things, by the stubbornness of matter. But if matter is just information, then reality is lighter. It is fluid. It is changeable. It is a conversation. The electron is not a wall. It is a word, and the conversation is ongoing. We are still asking questions. We are still firing electrons at slits. We are still building colliders to smash them open. And with every question we ask, the universe gives a new answer, rendering a new layer of detail, expanding the game, deepening the simulation, enriching the story. The silence of the room is now a silence of waiting potential. It is the silence of a computer cursor blinking on a black screen, waiting for a keystroke. The air around you is thick with uncollapsed waves, with questions that haven't been asked yet. The electrons in the darkness are swimming in their probability pools, waiting for the light, waiting for an interaction, waiting for you. This makes the act of living a sacred act of creation. Every time you open your eyes, you are collapsing wave functions. Every time you take a step, you are forcing the universe to decide where the floor is. Every time you breathe, you are turning the ghostly quantum mist into life-sustaining air. You are a collapse engine. You are a reality generator. And yet, despite being information, the electron is not abstract. It hurts when you stub your toe. It burns when you touch a hot stove. The bit becomes a very convincing it. This is the genius of the universe's programming. It creates a user interface that feels absolutely solid, absolutely consistent, and absolutely real. The resistance you feel, the Pauli exclusion principle, is the rule of the code that says objects cannot overlap. The gravity you feel is the rule that says mass attracts mass. We are living inside the most complex, beautiful, and rigorous logical system imaginable. And the electron is the smallest unit of that logic. As we drift through this informational landscape, the electron begins to look different, yet again. It is not a ball. It is not a wave. It is not a cloud. It is a qubit, a quantum bit, a unit of cosmic memory. It has a state, spin up, spin down. It has a position, here, there. It has an energy, high, low. It is a bundle of properties held together by the syntax of physics. And because information cannot be destroyed, a principle known as unitarity, the information that makes up an electron is immortal. You can smash the particle. You can convert it to energy. You can let it fall into a black hole, where it is preserved on the event horizon according to Hawking, but the bit remains. The record of its existence is written indelibly in the ledger of the universe. This means that you, as a collection of electrons and information, are also written in that ledger. The pattern that is you, the data that describes your thoughts, your memories, your body, is part of the universal data set. In an information universe, we are never truly lost. We are just recompiled. We are redistributed. The signal continues. Let us return to the mirror. the room with the double slits. The electron is approaching the barrier. It is a wave of possibility. It passes through both doors. It is a ghost. And then it hits the screen. Click. A tiny flash of light, a spot, a decision. In that moment, the universe has spoken. Here, not there. Here. That single click is the heartbeat of reality. It is the sound of the world becoming real. And you are the listener. Without you, to hear the click, to see the flash, to register the data, the loop is not closed. The circle is broken. So the electron needs you. The vast, ancient, infinite cosmos needs you. It needs your eyes to see its stars. It needs your mind to know its laws. It needs your consciousness to collapse its waves. You are not an accident. You are the necessary partner in the dance of existence. The electron spins, and you watch. The electron waves, and you measure. The electron hides, and you seek. It is a game of hide and seek that has been going on for 13.8 billion years. And it is happening right now, in the quiet center of your own being. We have now seen the electron as a bit of code, and we have seen ourselves as the programmers, or at least the players, of reality. But if the universe is information, does it have a limit? Is there a maximum resolution to the screen? This brings us to the edge of the smooth world and the beginning of the grainy world. It brings us to the Planck length, the pixel size of the universe. If we zoom in past the electron cloud, past the nucleus, past the strings, do we eventually hit a grid? Do we see the discrete chunks of space and time? And what lies beyond the grid? Is there a substrate, a motherboard, or is it information all the way down? The journey into the electron is a journey into the abstract. We are leaving the world of things and entering the world of pure thought. And in this world, the electron reveals its final, most humble truth. It is a mirror. When we look deep enough into the heart of matter, we do not see a little ball. We see ourselves looking back. We see our own questions reflected in the geometry of the void. The room is dark. The screen is dim. But the information is flowing. The bits are flipping. The universe is rendering. And you are there at the center of it all, the silent witness, the collapse engine, the dreamer of the dream. Rest in that power. Rest in the knowledge that you are woven into the logic of the stars. The electron is waiting for your next move. The journey is not over. We have dissolved the particle into a wave, the wave into a field, the field into geometry, and the geometry into information. But there is a future to consider. The electron is stable now, but will it last forever? What is the ultimate fate of matter? And could there be electrons that are not electrons? Could there be heavier, stranger cousins that lived and died in the first moments of the Big Bang? We must look at the family tree. We must look at the muon and the tau, the heavy ghosts that hint at a deeper structure. We must ask why there are 3 generations of matter and not 1 or 4 or infinite. The mystery of the generations is one of the biggest unsolved puzzles in physics. Why did nature make copies? Why is the electron the lightest? As we prepare to meet the heavy cousins, let the digital rain of the matrix fade. Let the bits soften back into waves. Let the it return. We are going to look at the lineage of the electron. We are going to look at the family album of the subatomic world. In the quiet gallery of the universe, where the fundamental particles hang like portraits on a wall, the electron has always been the star. It is the face we know. It is the builder of atoms, the weaver of light, the carrier of currents. It is stable, dependable, and eternal. We assume that it is unique, a masterpiece that nature painted only once. But as we look deeper into the shadows of the gallery, we find something unsettling. Hanging next to the Electron are two other portraits. They look almost exactly like the Electron. They have the same brushstrokes, the same negative charge, the same spin, the same interaction with a weak force. But the faces in these portraits are swollen, heavy, and tragic. They are the Electron's secret family, the heavy cousins that nature created and then seemingly discarded. Their names are the muon and the tau, and their existence is one of the greatest unsolved mysteries in the history of physics. To understand the strangeness of this family, imagine you went to a car dealership to buy a specific model of a car, say, a compact, efficient little sedan. You buy it, you drive it, and it works perfectly. Then, a few years later, you go back to the dealership, and you see the exact same car, identical in every detail. The same color, the same shape, the same engine layout. Except, this new version weighs 200 times more than the original. It is made of lead instead of steel. It drives exactly the same way, steers the same way, but it is enormously heavy. And then you see a third version, identical again, but this one weighs 3,000 times more. And the strangest part is that these heavy cars fall apart the moment you drive them off the lot. They crumble into dust within seconds, leaving behind only the original light version. This is the situation with the Electron. The first heavy cousin to be discovered was the muon. In the 1930s, physicists were studying cosmic rays, high-energy particles that smash into the Earth's atmosphere from space. They expected to find electrons and protons, the standard building blocks. But in the debris of these collisions, they found a particle that didn't fit. It had a negative charge like an electron, but it didn't behave like an electron. It punched through lead plates that would have stopped an electron dead. It was heavy. When the physicist I. Rabi was told about the discovery, he famously asked, "Who ordered that?" It was a profound question. The electron was necessary. It makes atoms. The proton and neutron were necessary. They make nuclei. The photon was necessary. It carries light. But the muon? It seemed to have no purpose. It was just a heavy, unstable copy of the electron, wandering through the universe like a mistake. The muon is approximately 207 times more massive than the electron. If the electron is a ping-pong ball, the muon is a bowling ball. But despite this bulk, it is not bigger in size. As far as we can tell, it is still a point particle. It is a point of mass, just like the electron, but somehow it interacts with the Higgs field much more strongly, dragging through the cosmic molasses with 200 times more friction. And because it is heavy, it is unstable. In the quantum world, heavy things tend to fall apart into lighter things. Energy wants to spread out. A muon lives for only about 2.2 microseconds. That is 2/millionths of a second. It is a blip, a flicker. In that tiny sliver of time, it exists. It feels the electromagnetic force. It spins, and then it dies. It decays, spitting out an electron and two neutrinos. One electron neutrino and one muon neutrino. The heavy ghost vanishes, leaving behind the stable, familiar particles we know. But the story gets even stranger with the third cousin, the tau. Discovered much later, in the 1970s, the tau is a monster. It is 3,477 times heavier than the electron. It is almost twice as heavy as a proton. Imagine that. A point particle that outweighs the complex quark-filled nucleus of a hydrogen atom. The tau is so heavy that it can decay into hadrons, particles made of quarks, which is something leptons like The electron usually never do. It is a bridge between the worlds, and its life is incredibly short. It lives for only a fraction of a trillionth of a second before exploding into a shower of lighter particles. It is a spark that burns too bright to last. So, we have 3 generations of matter. Generation 1, the electron and its neutrino. Generation 2, the muon and its neutrino. Generation 3, the tau and its neutrino. Why 3? Why not just 1? Why not 4? Physicists have looked for a 4th generation, a super-heavy electron, but they haven't found it. It seems the universe counts to 3 and then stops. This problem of flavor is the whimsical term physicists use to distinguish these generations, is a deep crack in our understanding. The Standard Model describes these particles perfectly, but it doesn't explain why they exist. It doesn't explain the pattern. It is as if nature found a good recipe and decided to try it again with more ingredients, and then again with even more, before realizing that the original recipe was the only one that could survive in a cold universe. But even in its brief life, the muon teaches us something profound about time. Because muons are unstable, they shouldn't be able to travel very far. Even moving near the speed of light, a particle that lives for 2 microseconds should only travel about 600 meters, less than half a mile, before it decays. But moons are created high in the atmosphere, 20 or 30 kilometers up. We shouldn't be able to detect them on the ground. They should all die long before they reach the surface. Yet, if you hold out your hand right now, a muon passes through it roughly once every second. We detect them deep underground. How is this possible? How can a particle with a half-mile lifespan travel 20 miles? The answer is Einstein's special relativity. Time is not absolute. Time depends on how fast you move. To us, standing on the ground, the muon is moving at 99.9% of the speed of light. At that speed, time for the muon slows down dramatically. Its internal clock, the ticking of its decay, runs slower relative to our clock. We see it live much longer than 2 microseconds, long enough to reach the ground. But here is the beautiful part. Ask the muon what it feels. From the muon's perspective, it is not moving. The Earth is rushing towards it at near light speed. And because of length contraction, the other side of relativity, the 20 kilometers of atmosphere is squashed into a thin sheet, less than 600 meters thick. The muon sees the ground rushing up and crosses that thin sheet in a fraction of a second, dying just as it hits the detector. Both stories are true. We say time stretched. The muon says space shrank. And in that reconciliation, the particle touches the Earth. This means that every muon passing through your body is a traveler that has experienced a warping of reality. It is a testament to the fact that now is a flexible concept. The muon is an impossible visitor, allowed to exist in our world only because it moves so fast that it cheats death. It brings the relativistic warping of space-time right into your living room. But let us meditate on the tragedy of these heavy cousins. The universe was not always cold and quiet. In the first moments after the Big Bang, the universe was hot, incredibly hot. It was filled with energy. In that primordial fire, there was enough energy to create moons and taus in abundance. They were not rare then. They were common. The universe was a soup of heavy, exotic matter. But as the universe expanded and cooled, there was no longer enough energy to keep making them. And the ones that existed decayed. They fell down the energy ladder. The taus became muons. The muons became electrons. The heavy giants vanished, leaving only the lightest, most stable offspring to inherit the cosmos. The electron is the survivor. It is the ground state of the lepton family. It is the bottom of the barrel, the place where energy rests when it has nowhere else to go. Because there is no lighter charged particle for the electron to decay into, it is stuck. It is immortal by default. Conservation of charge forbids it from vanishing. It carries the negative charge of the universe on its back, and it cannot put it down. This is why our world is made of electrons. If the muon were stable, if it didn't decay, chemistry would be vastly different. A muonic atom would have the heavy muon orbiting very, very close to the nucleus. The atom would be 200 times smaller. The chemical bonds would be different. Light would be different. Biology as we know it would be impossible. Life requires the spaciousness, the fluffiness of the electron cloud. We need the light, flighty particle to create the volume of our bodies. A universe of stable moons would be a universe of tiny, dense, inert dust. So, we should be grateful for the decay. We should be grateful that the heavy cousins die young. Their death allows the electron to rule, and the rule of the electron is the rule of complexity and life. But the mystery remains. Why are they there at all? Is the electron actually a composite object? Some theorists suggest that maybe the electron, muon, and tau are not fundamental. Maybe they are made of even smaller things, prions, arranged in different ways. Maybe the muon is just an excited state of the electron, like a guitar string vibrating at a higher harmonic. If you pluck an electron hard enough, does it become a muon? In high-energy colliders, the answer is effectively yes. If you smash electrons together with enough force, out pop muons and taus. The potential for heaviness is hidden inside the light electron. It is waiting for energy to unlock it. This connects back to the Higgs field. We said the electron gets its mass by wading through the Higgs molasses. The muon wades through the same molasses, but it feels more drag. The tau feels even more. Why? Why does the Higgs field grab onto the tau so tightly and let the electron slip through so easily? This is the coupling constant mystery. In the standard model, these numbers are just plugged in by hand. We measure them and write them down. We don't know why they have these values. It is one of the arbitrary settings on the dashboard of the universe. If the dial for the electron's coupling were turned up just a little bit, the electron would be heavy, atoms would collapse, and stars would burn out in an instant. We exist in a Goldilocks universe, tuned for the light electron. As you lie in the quiet, imagine the ghostly rain of moons continuing around you. Each one is a heavy electron, a fat electron, living its brief, relativistic life. They are passing through the roof, through your body, burying themselves deep in the earth. They are the echoes of the Big Bang, reminders that the vacuum has more potential than just the stable matter we see. They are the siblings that never grew up. They are the shadows of a family tree that has been pruned by the cooling of time. And what about the neutrinos? We mentioned that each generation has its own neutrino. The electron neutrino, the muon neutrino, the tau neutrino. These ghostly partners are also distinct, and they oscillate. They change into each other. This suggests that the generations are not separate silos. They are mixed. A particle can start as generation 1 and turn into generation 2. The walls between the cousins are porous. The identity of particles is fluid. This reinforces the idea that particle is just a temporary label for a state of the field. The underlying field can manifest as a light electron or a heavy tau, depending on how you look at it and how much energy you feed it. There is a sense of deep, ancient melancholy in the story of the generations. It speaks of a universe that has lost its grandeur. We live in the low-energy era, the era of the leftovers. The magnificent heavy particles of the beginning are gone, or appear only as fleeting ghosts in our detectors. We are built from the ash of the Big Bang, the stable proton, the stable electron. These are the cinders that refuse to burn out. But in that refusal, in that stubborn stability, they built a new kind of grandeur, not the grandeur of raw energy, but the grandeur of structure, the grandeur of the flower, the cathedral, and the mind. The electron, our humble protagonist, is the hero of this low-energy age. It carries the torch. It remembers its heavy brothers, but it does the work they could not do. It bonds. It builds. It flows. It creates the possibility of a future. But speaking of the future, we must ask, is the electron truly eternal? We said it has nowhere to decay into, but what if the vacuum itself changes? What if the rules of the game are not fixed? There is a concept called vacuum decay. It is the idea that the Higgs field might not be in its absolutely lowest energy state. It might be in a false vacuum, resting on a ledge on a cliff. If something were to nudge it, a quantum fluctuation, a high-energy event, it could slip off the ledge and fall to a lower state. A bubble of true vacuum would form and expand at the speed of light. Inside that bubble, the laws of physics would be different. The mass of the electron would change. Chemistry would be rewritten. Matter as we know it would cease to exist. This is a terrifying thought, but also a sublime one. It suggests that even the laws of physics are vulnerable. Even the bedrock is not solid. We are balancing on a ledge, safe for now, held up by the specific values of the fields that emerged from the cooling of the cosmos. The electron is our boat on this precarious sea. As long as it holds its mass, as long as it keeps its charge, we are safe. Let us return to the comfort of the room. The air is still. The muons are falling. The electrons in your body are spinning. The heavy cousins are distant memories, flickering in the upper atmosphere or in the tunnels of particle accelerators. You are made of the stable stuff. You are made of the survivors. And that stability is a gift. It allows you to have a memory, a history, a life that lasts longer than a microsecond. We have explored the family. We have seen the heaviness. We have seen the connection to time and the vacuum. But there is one final aspect of the electron we need to touch upon before we conclude our journey. It is the aspect of unity. We have hinted at it with the fields. We have hinted at it with the strings. But what happens if we try to put it all together? What is the final vision of the electron in a theory of everything? Physicists dream of a symmetry that unifies the electron with the quark, the force carriers with the matter particles. They call it supersymmetry. It predicts that every particle has a super partner hidden in the shadows. The electron has the selectron. The quark has the squark. These particles would be heavy, like the muon and tau, but even heavier. We haven't found them yet. Maybe they are too heavy for our machines, or maybe nature is simply not supersymmetric. Maybe the electron is lonely in a different way. But whether supersymmetry is true or not, the drive to unify is powerful. It is the drive to see the electron not just as a part of a family, but as a facet of a single, gleaming jewel that is the universe itself. As we end this chapter, feel the weight of the generations. Feel the presence of the invisible rain. You are not just a collection of atoms. You are a filter for the cosmos. You are transparent to the ghosts, but solid to the light. You are a bridge between the quantum vacuum and the macroscopic world. And the electron is the keystone of that bridge. In the next chapter, we will look at the technology of the ghost. We will see how our understanding of the electron has allowed us to build the modern world. From the transistor to the laser to the MRI, every piece of magic we possess comes from asking the electron to dance. We will move from the what is it to the what can it do, and we will find that the practical applications are just as mind-bending as the theory. We will see that we are not just observers of the electron, we are its partners in creation. We have spent this journey exploring the electron as a mystery. We have looked at it as a ghost, a cloud, a wave, and a bit of code. We have seen it dancing in the vacuum and hiding in the nucleus. But there is one final lens we must look through, and it is perhaps the most miraculous of all. It is the lens of utility, because this tiny, invisible, zero-dimensional speck is not just a philosophical puzzle. It is the workhorse of our civilization. It is the slave that built the modern world. Look around you. The device you are holding, the lights in your room, the internet that brought these words to you, the medical scanners that saved lives, the planes in the sky. All of it, every single bit of it, is possible only because we learned to tame the electron. We learned to make the ghost do our bidding. Consider the rock, a piece of silicon. For billions of years, silicon was just sand. It was inert. It was dumb. It sat on the beach and did nothing. But in the 20th century, we learned a secret. We learned that if we purified this silicon and doped it with tiny impurities, adding a few atoms of boron here, a few atoms of phosphorus there, we could create a landscape for electrons. We could create a maze. We could tell the electrons where to go and where to stop. We invented the transistor. The transistor is the simplest and most profound machine ever built. It is a valve, a faucet. But instead of controlling water, it controls the flow of electrons. And instead of being turned by a hand, it is turned by another flow of electrons. It is a switch that flicks itself. This sounds simple, but it is the basis of all logic. One flow of electrons represents a yes. No flow represents a no. By combining billions of these microscopic valves on a chip the size of a fingernail, we taught the rock how to think. We tricked the sand into doing mathematics. Inside the processor of your computer or phone, right now, billions of transistors are switching on and off billions of times a second. They are shuffling electrons around in a dance of unimaginable complexity. And every single one of those electrons is obeying the laws of quantum mechanics we discussed. They are tunneling through barriers they shouldn't be able to cross. They are respecting the Pauli exclusion principle to keep the signals distinct. They are surfing the waves of the electric fields we apply. We have harnessed the quantum cloud and turned it into a stream of logic. We have turned the probability wave into a text message, a video, a symphony. But we didn't just harness the charge, we harnessed the jump. Remember the quantum leap? The way an electron teleports from one energy level to another and releases a photon? For a long time, this was just a random event. Atoms glowed when they got hot, like in a fire or a light bulb. It was chaotic light, messy and scattered. But then, we figured out how to organize it. We realized that if we tickled an atom in just the right way, with a photon of exactly the right color, we could force the electron to jump now. And when it jumped, it would release a new photon that was an exact clone of the first one. They would move in perfect step. They would be coherent. This is the laser. Light amplification by stimulated emission of radiation. It is a waterfall of identical photons created by a synchronized army of jumping electrons. With this focused beam, We can cut steel. We can perform delicate surgery on the human eye. We can send terabytes of data through glass fibers across the bottom of the ocean. Every time you stream a movie, you're watching a light show performed by electrons dancing in a laser diode thousands of miles away. We have turned the quantum leap into the backbone of global communication. And we went even further. We decided that we didn't just want to use electrons. We wanted to see with them. We realized that light waves are too fat. They are too clumsy to see the tiny details of the microscopic world. If you try to look at a virus with light, it is like trying to feel a Braille book while wearing oven mitts. The waves just wash over the details. But the electron has a wavelength thousands of times smaller than light. It is a fine-tipped needle. So we built the electron microscope. We learned to fire beams of electrons at a target and read how they bounced off. We learned to focus them with magnetic lenses. With this tool, we opened up a hidden universe. We saw the face of an insect looking like a monster. We saw the structure of a protein. We saw the individual atoms in a crystal lattice. We gave ourselves eyes that could see the building blocks of reality. We used the electron to look at the electron's handiwork. It is the universe looking at itself in the mirror of high-energy physics. But perhaps the most touching application of our knowledge is in medicine. We learn to use the electron and its antimatter twin to heal. Think about the PET scan, positron emission tomography. We inject a patient with a sugar tracer that emits positrons, antimatter. Inside the patient's body, these positrons fly out and almost immediately hit an electron. Poof! They annihilate. They turn into 2 gamma rays that fly out in opposite directions. The scanner detects these rays and traces them back to the source. It allows doctors to see where the brain is active, where a tumor is growing, where the metabolism is struggling. We are using the violent death of matter and antimatter to save human lives. And consider the MRI, magnetic resonance imaging. This machine talks directly to the spin of the protons in the water of your body. But it is the electrons in the superconducting coils of the magnet that make it possible. These electrons are cooled to near absolute zero. In this extreme cold, they undergo a phase change. They stop acting like individuals and join together in a giant collective quantum state called a Bose-Einstein condensate. They flow without resistance. They flow forever. A current started in an MRI magnet will keep flowing for years, creating the powerful magnetic field needed to peek inside you without cutting you open. We have frozen the electron to see the warmth of life. And now we stand on the brink of a new era, the quantum computer. We are no longer satisfied with just moving electrons around like water in a pipe. We want to use their ghostliness. We want to compute with the superposition. We want to use the fact that an electron can be spin up and spin down at the same time to solve problems that are currently impossible. We are building machines where the bit is not a switch, but a wave. Machines that think in parallel universes. When this technology matures, it will revolutionize everything from drug discovery to climate modeling. It will be the ultimate mastery of the electron. But amidst all this technology, amidst the silicon chips and the lasers and the scanners, we must never lose sight of the profound mystery at the core. We are building our civilization on top of a riddle. We can predict what the electron will do with 12 decimal places of accuracy. But we still don't truly know what it is. We are like a person who has found a magical flute. We have learned to play incredible songs on it. We can make it rain. we can make it sunny, we can heal the sick with its music. But we still don't know who made the flute, or why it works. We just know the fingering chart. This brings us back to the start of our journey. The wonder. The science has not killed the wonder. It has deepened it. It has taken the simple mystery of what is that rock and turned it into the deep mystery of why is the universe a field of vibrating probability? It has shown us that the mundane world is a veil, and behind that veil is a dance of unimaginable beauty and complexity. As we reach the end of this script and the end of this journey, I want you to return your awareness to your own body. Look at your hand. Really look at it. You see skin, lines, texture. But now you know the truth. You are looking at a galaxy of empty space. You are looking at a swarm of probability clouds. You are looking at a cathedral of spin. Inside that hand, 7 octillion electrons are singing. They are rushing through your nerves to carry the sensation of touch to your brain. They are bonding the carbon and oxygen to keep your skin intact. They are fighting the gravity of the earth to keep your hand lifted. They are absorbing the heat of the room. They are reflecting the light of the lamp. They are busy. They are tireless. They are ancient. And they are you. You are not separate from this quantum dance. You are the dance. You are the way the universe is experiencing itself. For 13.8 billion years, the cosmos has been cooling, expanding, and evolving, just so it could create a stable platform, a body, a brain, where electrons could flow in such a complex pattern that they became conscious, that they became aware, that they could ask, "What am I?" The electron in your brain is asking about the electron in the text. The mirror is complete. This knowledge should not make you feel small. It should make you feel vast. It should make you feel connected. You are woven into the fabric of reality by forces that are stronger than steel and older than time. You are safe in the arms of the laws of physics. The Pauli exclusion principle is protecting your space. The conservation of energy is protecting your substance. The speed of light is protecting your causality. You are a child of the universe, made of its most fundamental dust, animated by its most fundamental fire. So, the next time you feel lonely or overwhelmed or afraid, remember the electron, remember the cloud, remember the spin, remember that deep down, in the quiet center of your atoms, there is a perfect order. There is a harmony that never breaks. There is a light that never goes out. The journey of discovery is an infinite loop. We answer one question, and 10 more appear. We find the electron, and we find the quark. We find the quark, and we find the string. We find the string, and we find the bit. And that is how it should be. A universe that could be completely understood would be a dead universe, a boring universe. The mystery is the fuel of our existence. It is what gets us out of bed in the morning. It is what drives us to look up at the stars and down into the microscope. So keep looking, keep asking, keep wondering, because the universe is not just outside you, it is inside you, and it is waiting to be found. As you drift off to sleep, or as you go back to your day, carry this feeling with you, the feeling of being light, the feeling of being energy, the feeling of being a mystery wrapped in a ghost, exploring a world made of dreams. The electron is just the beginning. There are other particles, other forces, other dimensions waiting for us. The library of the cosmos is vast, and we have only read the first page. But what a beautiful page it is. Thank you for walking this path with me. Thank you for peering into the void and finding it full. Thank you for being a curious observer in this grand participatory universe. Sleep well, fellow traveler. The atoms in your body will keep watch. The electrons will keep spinning. The universe will keep breathing. And when you wake, the mystery will be there, fresh and new, waiting for you to touch it again.